syndicate, as well as numerous donations by people with sometimes very limited revenues, should be thanked for what concerns the very heart of what we have, that of democracy, which will not be pushed away by ideology. So, by way of conclusion, I would like to read a letter by among the hundreds we received, Veronique, who will write others, and still with financial support. Thank you for your courage, your fight against obscurantisms that the elite still cling to. Thank you to all who allows us not to collapse into the catastrophic vision of the governmental class and the media, whom we no longer listen to. Thank you for providing us access to freedom. Thank you. Do not give up. This comedy has to stop. For those who gave us our donation, who wants the freedom and support scientific righteousness, well, we will never allow any ministry of Orwellian ministry of truth to prevail. Thank you very much for your attention. I give the floor now to Laurent, who allowed all the scientists to be here today. Il aurait dû aller plus vite, lui. Ouais. Allez, les mecs, quand ils lisent des textes comme ça, c'est toujours infernal, ça. We changed the program slightly because Didier Raoult had things to do, so he cannot be with us. C'est bon, laisse. De toute façon, on les prend à la volée et puis on va débrouiller. Ouais. Si éventuellement, ouais, après cet après-midi, on peut avoir des lampes de table et puis couper ces lumières, là, ce serait... Sorry, let's try to catch up. We're somewhat running late. I want to advance in the list of thanks, by the way, because you know, he's been working very hard for the organization of this conference. So I will answer three questions. So that to start with, first, why this colloquium? How? And third would be, why in the IHU in Marseille? First, why? Why? Simply because, in fact, clearly there is no intellectual debate about the COVID crisis for the last 2 years. There is a kind of you know, stone covering public debate. You know, it's like a, you know, and especially scientific debate. Official discourse claims to have some scientific consensus, which is a rhetoric. It's purely a rhetoric approach. It's like power to say. We are in a large number to consider that for the last 2 years, been challenged, and public policies, inefficient and discriminatory, have been imposed in the name of science. Therefore, not only can we, but we must talk about it among ourselves. I think this is part of our social mission. And I would like to add to some of my colleagues, this social mission should not be done when it's easy because everything goes smoothly and there is no challenge. No, we have to do it. We have to implement it when there is a crisis and there are immediate challenges, and it's far more difficult. Let me add as well that we don't do it for the time being, you know, immediate situations. We do it for the future. Because if we all together, global society, have been able to make all those mistakes, you know, the mistreatment to population, all the, you know, the fact that we renounced solution, what's going to be the next crisis? So the need to understand, the need to know is disturbing, clearly. Vincent mentioned there were media and political pressures, amazing, to prevent this conference from taking place. A media campaign, a bashing campaign was run out in the last 2 weeks, and it was amazing. We never had believed that, if been told beforehand. Well, I had to organize about 20 colloquium in the study days in Macquarie. This is the first time that I have journalists paying into this. First time they write papers before the colloquium has taken place. And the first time that they write papers that had no relationship with the program of the conference. Program which clearly they're not interested in. All the papers I've read in the press for the last 2 weeks are attacking the organizers and the speakers of the conference before they've actually said anything. They are attacking individuals so that they don't have to discuss their ideas. We are being told by a bunch of anti-vaccine and complotists to deny, to discredit our talks regardless of the content. So let's go for it. Since we are being attacked, let's respond nicely, but by stating things and by stating the newspaper Le Monde, and it's not the first time, is this spokesperson for the government by attacking a colloquium that gathers personalities that challenge the scientific consensus on COVID-19. The old argument of authority. And so they support this idea. Now, example, our colleague from INSER, Laurent Toubiana, who is here, who will take the floor this afternoon, who becomes the author of a study on overmortality in 2020, rejected by the scientific world. So, what study? The one we published, which were 4 authors, Pierre Saillot, INSEE, Japos, PHP, or the one we published beforehand, 3, François Toussaint with physiology teacher in Paris. And what scientific world rejected it? In what review? Scientific review? At what date? By signed by whom? No indication. I don't know. Another example. A journalist from France Info is not really paying attention to who we are and what we said, that he doesn't get in touch with the organizers to know about the program. And by the way, he interviews a person who is one of our speakers, Claude Escarguel, who's here, who the next morning in the newspaper will be Dr. Escargot, and you understood, Claude, that, by the way, the guy wanted to find someone to say, interviewed someone from, but that's a trick. But the title and the heading of the article was already written, and they just use your name to justify the article. But the top of intellectual dishonesty, was reached by La Provence. Sophie Manelli is insulting us, and and is actually, labeling. We are a gathering of people who think that the Earth is flat and the Michael Jackson is still alive. Yeah. Je l'ai lu l'article. We don't know where we're gone. This is. It's no longer gutter press. It's I don't have any category to define that. And this description is not just words. Words have consequences. What we're missing today and tomorrow, 2 colleagues who were happy to have this colloquium and who actually pulled out of the colloquium at the last minute. They were so much media pressure, they pulled out. They self-censor themselves because they don't want their reputation to be stained and to have consequences in their own professional world. That's reality. And 2 other of our speakers were just about to do it, to pull out as well. So now come back. Tomorrow I'll come back to the operation of media and social networks in the part of dedicated to controversies. But let me conclude this about the media by saying that, unfortunately, journalists never ask the first question that is to be asked. Who are we disturbing? Who are we disturbing? So why do you want to shut us up? Who fears us so much, that they're so scared of people thinking and discussing for 2 days. Second point, now, how the colloquium? Well, for several months. I wanted to do a colloquium around the, to come out of the COVID doxa collective, but there is an organization and a budget, and I didn't see how we could do it. When Vincent Pavant and the Research and Liberty asked me if they would be ready to organize a conference for the International COVID Summit, I decided, yes, let's do it. In its construction, this colloquium actually is taking resources in the pluridisciplinary network, plus IHU researchers, colleagues from Marseille, and 3 US colleagues, whom I want to thank warmly for their participations. The field of knowledge that will be discussed in the next 2 days is not exhaustive, but nevertheless, it shows a certain pluridisciplinarity, which will contribute to report about to express the complexity of reality. The scope of the colloquium is even more narrowed because 2 half days dealing with 4 thematic portions. First one will be dealing with biological aspects, and I've asked Jacques Fontini, biology and molecular biology in Expo to facilitate the session. This afternoon, the second thematic session will deal with the epidemiological issues, and I've asked Jean Rousier, rheumatologist, medicine professor at Aix-Marseille University, to facilitate the session. Tomorrow morning, third session, that of care and patient management. I've asked Dr. Bernard Giral to facilitate this session because through him I wanted to acknowledge and associate the doctors on the field to our reflection. And finally, fourth half day, the issue of scientific controversies. And I've asked Eles Palma, professor at Marseille University and Secretary General of the Research and Liberty Teaching, to facilitate the session. Thank you again to all the 4 facilitators. Third and last question, why in the Marseille IHU? Several reasons. First, all the organizers and the participants are in the Bouches-du-Rhône department. If we'd been for Paris, we would have been in Paris, no problem. Second reason is an intellectual choice. If we're here, it's because we are aware of the major diversion that has been in action for the last 2 years against the IHU and its director. You at the IHU were subjected to political administrative bashing and harassment, but also at the media level through moral bashing, with psychological and symbolic violence, which were quite amazing. You were called, clowns, liars, like people who were poison patients, but you held on. And you did a huge amount of work, not only in research in care, which is the mission of public service, which is Hospital University Institute. So, if we're here today, for me and for most of you, a way to pay tribute to this work and to this persistence and fortitude and we are groupies. We're fans. We don't repeat things. We don't want to hear criticism. No, it's not that. We are open, but we're trying to think. And we are not repeated political industrial propaganda. And through the publications of IHU, emissions which are broadcast on the channel, the research seminars or organized by Professor Semyon, through these works you helped us to think, to be wiser, more knowledgeable. This is why I'm quite happy to be here to open this colloquium. Thank you for your attention, for your support, and have a great conference. I need a microphone. J'ai pas de micro de l'orateur là. J'ai pas de micro là. Sorry. Faut qu'ils attendent en fait entre chaque mec. I'm very happy. Mais non. I'm sorry, we're not getting the sound from the speaker, so il est quoi en bouffée de la paille, lui? So they know that I said thank you to the technicians, and you know, they do research, but lui il a le micro, il s'en va de l'orateur, tu as tout compris. Il a tout compris. Non mais là c'est bon.
Ouais, c'est dans la poche ça. Bon, ils ont entendu Christian Tourès, Natacha Tivoulis.
Well, you know, they heard the name of Philippe Colson, Catherine Tamalé, Noura Hamid. You know, I pay tribute to them because, you know,
c'est quand même eux qui ont découvert,
they discovered the first mutations in the genomes of patients today in tritherapies. They showed the insertion deletions we are talking today about, you know, 25 years later with SARS-CoV-2. So if they had not done that work beforehand under the heading and well, you know, the caring of Didier Raoult and the authority of Didier Raoult, you know. Well, I'm a scientist, professor of biochemistry and molecular biology at Aix-Marseille University. I've been asked to facilitate this scientific half day. I do it with great pleasure because science works with men and women. Science functions with discussions, debate. I don't know what the scientific consensus is all about because there must be debates. We have them in labs, we have them in universities. I have them constantly with my students. So each course is a discussion, a debate, and honestly, this is part of our profession and more of our vocation to facilitate the discussions and to be involved in these discussions, debate with independence, you know, openness, stringency. No question is a stupid question. All questions should be asked, should be debated. Sometimes they can be sort of the leading ideas, sometimes not. What I'm teaching today, I did not teach 10 years ago because knowledge has evolved, and this is the very reason why we're here today. This is the way I experienced this invitation, and I really wish this conference and this half day that I will facilitate, you know, high-level scientific debate, and the quality of the speakers is the guarantee of the discussions will be of high quality because there will be Pierre Soligo, Hélène Banoun, Robert Malone, and I give the floor now, and something that's most interesting, she was a former INSERN researcher. Hélène did huge amount of research on the origin of SARS-CoV-2, and this is what she's going to talk about now. Bon, on va pas chômer, hein. Ça va? De toute façon, il y a une règle. Tu démarres ta session. Bon, bah là, je vais aller parler avec toi. Par exemple, tu démarres. Si à un moment donné, tu sens que tu décroches, tu me le dis. Il faut pas. C'est pas un problème d'ego, ce métier. Si à un moment donné, tu sens que tu n'attrapes plus, tu me fais signe, je prends.
Bonjour, donc je suis Hélène Banoun, je suis pharmacien biologiste ex-chargé de recherche.
Research manager for the INSEM. I'm part of the MSIM, International Association for Independent and Caring Scientific Medicine, and an independent scientific council. The full text of what I'm going to talk will be on ResearchGates with all references, because I got 100 references. I've placed a few at random, but you know, it's impossible to put everything here. Now, let me talk about the origin of the virus. We have to define what is a natural or artificial origin. For a virus, if we admit that the virus is a natural origin, it means that, well, we know it is zoonosis virus. It can infect man and cause a pandemic, so it has the capacity to be transmitted immediately, efficiently from man to man, which is not the case of SARS-CoV-1, for which there would be several introduction of wild animals, which did not cause the pandemics of SARS-CoV-2. This is not the cause of MERS or Ebola, which caused small local epidemics from wild animals to man. So that would be a natural virus. Then, what is the non-natural origin? Well, I use artificial or synthetic terms. The non-natural origin, that is artificial, means that this would be a virus coming from the bat, the bats, often there's, but which has been cultivated in a lab, either in a strain, a lineage of strain or an animal, and that escapes from the laboratory. That's the artificial, and this virus may have undergone voluntary or involuntary modifications. Voluntary modification would be human intervention to modify its sequence, possibly total synthesis from a modified sequence versus that was known based on a computer, and which would be modified versus the known one. Or it could be, accidental. They could be, for example, by shifting to cell cultures, which would modify to natural evolution. In all cases, from this non-natural origin, there is always a mandatory passage to culture cells. Now, the last development, because let me mention them, in the US, amendment will be presented on April 4, 2022 to ask the Ministry of the publication of all documents related to WIV, and that is the Wuhan Institute, which is at the origin of COVID. On March 15, 2022, a bipartisan group of the US Senate voted a draft law to establish an independent investigation commission for the origin of the virus in Europe. March 2022, 18 scientists asked the European Commission to launch an independent investigation, very much like the US Senate and investigation. Europe is also financing the Wuhan laboratory. And on February 26, there was a Warabé article et al., pronunciation. This article starts again the hypothesis of the natural origin, that is the Wuhan animal market, but it provides no new elements, and it brings it goes back to mid-December 2019, whereas now we know that the virus came before that, because there were two studies of zero prevalence in Europe, because as November 2019, already part of the population was already immune to SARS-CoV. As you see, sorry for the photo, sorry. I'm talking about, between politics and biology, we talk about 2 minutes about biopolitics. This is a concept that was elaborated by Michel Foucault at the end of the 70s. Biopolitics is specific policies of human population, which is there to optimize its reproduction and productivity. Because from an economic viewpoint, the health situation of a population that is employed and employable must be normalized so that it can be reproduce itself and be productive. States, therefore, very much as for the economic domain, they want to do stress test, to like very much in banks, they want to anticipate on the response to emerging virus pandemics. That was the case in the US when the USAID agency launched a predict research program, and the ARPA launched a program, DARPA, called Preempt. We'll discuss it later on. That was decided in the program. In Europe, there was also the EVA project, which is there to anticipate the answer to emerging viral disease. Now, these biopolitics or policies includes vaccination. For a long time, this has for a long time been part of biopolitics. And this is a quote from Bernoulli, a mathematician, 1760, who said, if we adopt inoculation, that was the name given to before vaccine, there will be a gain of several thousand of people for civil society, even though if it is deadly, as it kills children in the cradle, it is better to smallpox who kill adults who are useful to society. So basically, you improve the health of the population, sometimes to the detriment of some segment of that population. Bernoulli concluded that if we ignore the viewpoint of the individual, it will be always geometrically true that the interest of political powers is to prefer population. So biopolitics now is been focusing since the last 2000 on generalized vaccination, because the United Nations would have 100% of the global population to be vaccinated in 2030. In 2018, the European Union Council proposed to reinforce cooperation against vaccinal prevention of disease. And in 2021, experts from the financial and medical world were worried about the importance of the vaccine industry versus science, which would push science behind economy, which is what is taking place today. Now, back to biology after biopolitics. So, I mean, let's review what are the molecular characteristics of SARS-CoV-2, which are essential for its pathogenicity and transmissibility, that is, the fact it could trigger epidemics. First, you probably heard about the furin site, which is a polybasic site which separate the membrane politics with the membranes of the mammals. This furin, of course, it was obvious for the virologists that was obvious as of January 2020. That was the first element of the molecule. Other virologists, including Professor Montagnier, HIV, understood that there was homology sequences in the SARS-CoV-2 virus with HIV virus. Then, what's striking is the high additivity of the binding domain of the spike RBD, for the HACT2 observed as of the first isolates. And I'll talk other virus cell receptors which appear, the LFA1 and DC sign. We'll discuss that later on. And all those molecular characteristics are essential because the virus described in the Diffuse project of EcoHealth Alliance, it's a US NGO. Well, all virus proposed in this project should contain the same molecular characteristics. So the furin site. This was from the article of the French article from Salar, Holden, and Crowley. So furin, as I said, it's an enzyme present in numerous cells and which can cleave spikes in S1, S2. What you have to understand that the polybasic site of furin is PRR1. That is, you could see it here. It is between amino acid 680, 684 of the spike. Then the second characteristic is the high affinity of the binding receptor for the SCE2 in humans. So this affinity is higher than that of SARS-CoV-1, from 2003. Affinity of the binding domain of SARS-CoV-2 is higher than SARS-CoV-1. And this affinity for a human ACE2 is higher for the affinity of SCE2 for all species proposed as source of virus. As the first isolate, SARS-CoV-2 is better suited to man, a more affinity with man than any other species. And in 2003 epidemics, during the epidemics, the affinity of the binding domain went from weak to high, when at the beginning there was a high affinity.
Here are two graphs from two different articles. They show on the left and then in red all an affinity for humans related to the SARS-CoV-1 and SARS-CoV-2.
En haut à droite, vous avez les coronavirus qui ont des
And on the right, we have the inside coronaviruses, SARS-CoV-2, MERS, and Rubenine coronavirus, but there are no coronavirus that have both a furin site and a high affinity. I'll discuss other receptors later. It's important, but there's a receptor for LFA, leukocyte function associated. It's an antigen, and it lets the virus to enter a lymphocyte that doesn't express human. And this LFA is also used by HIV to bind the lymphocyte CD4. And there's another receptor, really important, the DC sign. It is a molecule expressed by the dendritic cells and their monocytes and macrophages. And this DC sign binds on the protein and HIV protein 2. So SARS-CoV-2 and SARS-CoV-1 and Ebola enter cells thanks to glycan that are on their receptors for DC sign, and these glycans are really important, but we'll discuss them later. There are 4 homology sequences with HIV. These have been noted by a virologist specialized in HIV. And these sequences were published by Indians. They withdrew their article, not because it was wrong, but because they were widely criticized and they didn't want to be insulted, so they withdrew the articles. But their result was never contested by a scientist. It was, on the contrary, confirmed by Perez and Montagnier. So this graph has been annotated by a virologist, an anonymous virologist on Twitter. Their account was cancelled. And on the left there is a representation of the spike protein. You can see a different characteristic of the HIV in red and yellow. They're on a receptor side, they're really accessible, and the furin is in green. The sequences are similar to the HIV. Here are some references. I'll be brief. I just want you to know which articles have confirmed those homology sequences. Salard and Hall, 2 French biologists, say that these sequences might have occurred naturally while coronaviruses have evolved, but these sequences might have been optimized too, and we'll discuss it later. This furin site isn't enough for the pathogenesis of the virus, so we need more. There have been publications on the matter. So we need this sequence, the furin sequence of HIV. You can see here below, as well as the furin site of SARS-CoV-2 PRRA. So this sequence is also to be found on the HIV sequence. So there are many similarities. To sum up the controversy about the origins of the SARS-CoV-2, so I mentioned in our report of the WHO. So this is an article from April 2021 that was published after the WHO report with 4 hypotheses, 2 animal hypotheses. So the virus would have animal origin. So there are many viruses, many animals, and there's one animal that would have transferred one virus to the human. So the animal carries many viruses, and one of them might have entered a human body. However, there is no animal that could have been an intermediary, and when we looked for intermediaries, but there was no such virus on the animals we analyzed. And there's another hypothesis that was pushed aside because it doesn't provide any scientific explanation. And there's a 4th hypothesis that is on the WHO report, and that mentions a lab leak. It is quite unlikely, according to the report. There have been gain-of-function experiments carried out in Wuhan that was co-financed by the NIH. And so this hypothesis is compatible with what we know. So what are the main arguments? First of all, there would have been a lab leak. There have been a lot of information on the matter, especially for SARS-CoV-3, or rather SARS-CoV-1 in 2003, that has escaped, that has leaked from laboratory several times. So the molecular characteristics of the virus were again function research. Gain of function research is the virus that gains the possibility to attack humans. So it is about optimizing receptors. So all these characteristics were part of the program that aimed to anticipate the emergence of a potentially pandemic virus and to anticipate the development of vaccine strategies to respond to this pandemic. So this program was partially implemented. We don't know what has been done, what has not been done, but before this program was implemented, there had been many experiments of a furin insertion in the HACE2 to optimize coronaviruses. And now I'm not going to read everything. We don't have enough time. So it started in 2004 with a furin site insertion patent that didn't regard coronaviruses. And very often there is, you will hear about a Professor Baric and another NGO and Peter Daszak. So in 2014 there has been a chimeric virus that had been created by inverted genetics. It had been cultured on bats in 2015. Another spike had been created and it has the possibility to be binded to HACE2. It had been inserted and expressed in the genome of a SARS-CoV. Peter Daszak justified this prevention program. He was aware of the risk of pandemics, but he thought it was interesting. And Ralph Baric had also raised the issue of the benefits of this experiment in 2017. The Daszak group from the Wuhan Institute had created 8 chimera with a different binding domains presence in similar SARS-CoV. Ralph Baric from the University of North Carolina has claimed during an interview in 2019 that in 2019 he said it was possible to create a chimeric virus without leaving any traces, contrary to what happened in 2015. It means that you can create a virus without leaving any traces, and the answers you're looking for are only in the Wuhan laboratory, and he was the one who asked the laboratory to carry out the experiment. And we created a chimera in 2015 with this SARS virus with a professor. So there has been this was the result of genetic modifying then, but we cannot say the same today, because you can find fragments of DNA that you can order to a company. Those are synthetic viruses, but he doesn't say that. In SARS-CoV-2, there are elements that suggest there has been genetic modification. So within this group of research suggested some hypotheses for the origin of SARS-CoV. According to them, there are natural origins. Zheng Lishi said that the virus came from the air TG13, but for many biologists, it is not a virus that was isolated. It has been constructed by a computer, and there are 70% similarities in the RBD, so it cannot be the direct virus who directly originated. So this natural origin is based on a spillover, that is a transfer from man to human, but SARS-CoV-2 isn't adopted, doesn't go well with bats. So what about the pangolin? So there's no intermediary virus that originated from a recombination between bat and human beings. As a reminder, in January 2020, the furin site was noticed by virologists, and there was an article written by Pradhan. But first of all, there was an article in Chinese. It hasn't been translated, and then there was the Pradhan article. And later on, a first French article that was published by a local virologist and that analyzed the furin site, and that was quite a surprise to find some polybasic bases in the virus. Zheng Lishi published the alignment of amino acid sequences of the subunit S1 But they didn't go further with the comparison. They didn't take the comparison up to the furin site, and they said that all the similarities were to be found outside of the furin site. So that was just before the furin site was found. So she says that SARS-CoV-2 comes from the sequence that was isolated in 2012, and apparently in 2020 she didn't notice that area TG. She didn't notice that there was a binder that could get the virus to human beings. So she forgot the furin site, she forgot the RBD, and it is really hard to believe. So here is the alignment with a amino acid sequence. And here's a picture of Peter Desac. I don't want you to see his face. I just want you to see that he is having a civil discussion. This is Peter Desac, president of EcoHealth Alliance. He was part of the commission that was sent to Wuhan with WHO. He was part of the investigation commission. So there's a huge conflict of interest. In 2020, he gave an interview at the television, and he said, you can manipulate the virus in the laboratory. The spike protein is responsible for the capacity of the virus to infect an animal. You can modify the sequence of the spike protein. And that's what we do with Rolf Barrett, with inside the sequence of the protein in another virus, and we're trying to develop a vaccine against this new virus that we are making, to produce and to anticipate a pandemic. Here's a reminder about gain of function. In 2011, 2020, 2012, there was a huge discussion about gain of function, and there was some publications about, so that was about N1H1, and in 2014, we talked about gain of function experiments. They were prohibited for influenza, MERS, and SARS viruses. This prohibition was removed in 2017 by Francis Collins. There was Donald Trump at the at the presidency of the United States. There was no Secretary of Health, so that's the moment he chose to remove this prohibition. And when there was a discussion about gain of function in 2012, Anthony Fauci was the director of the National Institute of Allergy and Infectious Diseases. He he defended gain of function research and said that there were more benefits than risk. He also said that nature is the most dangerous bioterrorist. So we're in the middle of biopolitics. And now a few words about this report from the Diffuse project that was given given to the DARPA call for proposition. So these documents were declassified. The government has to declassify, to make document public about all projects that have been financed by a national fund. So a citizen asked for this declassification. So this research project was made by DARPA, and it aims to protect its soldiers that will be sent away from future emerging viruses. So there are researchers to anticipate the emergence of future coronavirus that could lead to a pandemic. So this research is about creating models to anticipate this pandemic. These models, this template, are being assessed by in vivo experiences, so you can show the viruses can be transmitted from one species to another. And this research aims to prevent this virus from spreading from their animal reservoir to other species. So to respond to these projects, EcoHealth suggested that we could build a virus with the same the characteristic necessary to lead to a pandemic. So with a RBD that can bind to the ACE2 human receptor with a cleavage site, with the furin cleavage site, furin being an enzyme, with glycosylation site for spike. So we are talking about a SARS related, and there's this R that refers to gain a function that could modify the virus. So the DARPA noticed everything. So this project was reviewed in order to be able to get other funding if possible. So I'll be brief, but they were sure they created a model of a new emerging virus. So they are traveling through time, and they suggested vaccinated bats against this virus they made up. So they made a machine to get a vaccine for bats, and bats will get the injection in their caves. So they had already made the machine to produce the vaccine. So this project was made in collaboration with the DARPA, but there is already another project with the NIH about the reverse genetics and working with SARS-CoV. And this project has already created a very pathogenic, a highly pathogenic virus that can produce a viral load that is a lot higher than current viruses. So but there was already another project about MERS to create a MERS-2. The funding was renewed in 2021, excluding China, which means that they believe somehow that there was a lab leak. And I'll be brief. Moderna works with DARPA, has been working with DARPA in 2013 to develop mRNA vaccines. So there's a lot has been said about the Moderna patent. A lot of work has been done on foreign site, but not on a correct, accurate sequences. So what I mean is that Moderna works on different molecules as different work, and there can be a link here that can be found between the two institutions. There's also an agreement for a technology transfer between NIAID and Moderna that was modified to add vaccine against MERS and about foreign site that appeared in 2019. We might wonder if the result of all these experiments were not already known in 2017, since in 2017 Anthony Fauci had announced that there would be a surprise epidemic during Donald Trump's mandate. In 2019 there was a conference on influenza vaccines, so Anthony Fauci and other representatives were sorry that these influenza vaccines were quite old, and he suggested with Margaret Hamburg, they suggested together to go beyond clinical trials for mRNA vaccine with a disturbing crisis and to put them to market without further trials. So that was in 2019. So there's also another email that is quite interesting from Peter Daszak that says that it is extremely crucial that we don't publish these sequences, because this would have meant that these sequences are the same as the SARS-CoV-2 sequences. How can we connect all these sequences and experiments about SARS-CoV-2? And I think that Rolf Barrett can play a key role, because in 2015 he received funding for research on an attenuated living vaccine against SARS-CoV-2. He also received funding for carrying out research on mucosal vaccine against the HIV. So one might wonder that if we admit that the virus has a synthetic origin, so does it come from a research about an attenuated living vaccine, or does it come from another project like the Diffuse project? Is it an attenuated vaccine against all coronaviruses? And by the way, in China, there were vaccine trials against HIV that was based on an influenza, a vaccine against attenuated influenza. So everything is quite consistent, but the only people that have the answer to these questions are Rolf Barrick, Peter Daszak, and now I will go even faster. I have no time. So the SARS-CoV-2 has characteristics that make us think that it has been produced for an attenuated vaccine. And now, will there be a SARS-CoV-3? A new regulation was announced in 2021 by the US government, and it warns level 1 and 2 laboratories, warns them against the building producing chimeric viruses with the inclusion of SARS-CoV characteristics that take part into the inflammation. So it gives us the impression that there's a research going on about SARS-CoV-3 in the US right now. And now I would like to thank all the virologists who've been working with. Most of them are anonymous. They don't want their name to be known. And as a conclusion, I would say that Peter Daszak, Rolf Barrick, and Zhang Lixian are the only ones that who can tell us if SARS-CoV-2 has been made by man or has there been a lab leak, maybe voluntary or involuntary. Thank you. Thank you very much for your presentation. I think we can start a discussion, and I would like to give you a few information about the about HIV sequences. I'm not convinced about what I heard. And
On traduit que la présentation. Exactement. Parce que du coup, ils ne veulent pas qu'on diffuse les questions, parce que si jamais il y a des questions embarrassantes, questions problématiques, on est mort. Donc,
ça concerne des zones.
Je sais pas, c'est leur accès.
C'est ce qui vous emmène.
Ok. Du coup, pour vous, les questions, c'est off.
Ok. Vous savez, là, on a le micro éteint. Est-ce que nous
ça, c'est off, c'est juste pour moi.
Ok. Ça va.
Donc, si vous voulez aux toilettes, vous pouvez l'enlever.
Super.
Ouais, il vaut mieux d'ailleurs.
Ouais, je gérer.
Bon, ça va?
Ça va, c'est
Alors attention, un domaine de liaison, c'est pas un binder, c'est un binding domain.
C'est...
Le binder, c'est un agent de liaison.
Ça m'a échappé.
Non, je te dis, hein, parce que
Binding domain.
autre chose, fais attention, quand à un moment donné, elle a dit des trucs de 10 000 participants, un truc comme ça, elle a dit numerous. Non, là, l'important, c'est le chiffre. D'accord. Donc il y a une différence en disant, si on te dit il y a de nombreux chercheurs, si on te dit il y a eu 10 000 patients, il faut donner le nombre de patients. Ça, c'est une information. Encore une fois, ce qu'il faut, quand tu es dans de la communication scientifique, c'est quelle est l'information clé. Si elle dit 10 000, c'est que pour elle, c'est 10 000, ça a de la valeur. D'accord?
Voilà. Oui, je sais bien, mais
non, j'entends bien. Simplement, on fait un petit coaching.
D'accord.
Bon. Encore là, ce qui est essentiel, tu vois, c'est de vraiment comprendre. Quand à un moment donné, j'ai vu passer une diapo, je sais pas ce qu'elle disait, puis elle dit il y a eu 10 000, et tu as dit, j'ai entendu que tu dis numéro, si je sais pas où, 1000. Bon, non, ça marche pas. Là, 10 000, c'est un chiffre, elle donne ce chiffre, il faut. Si elle dit, je sais plus ce qu'elle dit, attends, il y a un truc, on suit à des points de vue, il faudrait. Bon. Ok, il n'y a pas de valeur, toi tu peux rentrer dans quelque chose. Mais dès l'instant où il y a une valeur, et que cette valeur elle est liée à des sources de polémique, là il faut absolument la donner. D'accord. Ça, il faut que tu fasses ça. Ça, c'est un tri que tu as à faire en permanence. C'est aussi ça dans notre métier, c'est de trier l'information. Moi j'appelle ça de la discrimination d'information. Qu'est-ce qui est essentiel, qu'est-ce qui n'est pas.
Est-ce que je vais aller aux toilettes?
Je t'en prie. Comme chez toi.
J'allais dire quelque chose et puis je...
Super.
Merci.
Non, c'est ça. Non, mais t'inquiète pas, ça repart.
Parce que mine de rien, on a beaucoup bu.
Mais il faut boire, voilà.
1, 2, 1, 2, 1, 2, 3, est-ce que tu m'entends? Il y a des intervenants qui surgissent des murs. Est-ce que nous allons tester un
on diffuse les questions, finalement. Ok. Ok. Il y a les questions. Passons. C'est un peu de coulisses. Là. J'ai pas le son de place au niveau, moi. C'est pas le cas. Excusez-moi, je vais me présenter. Allez-y, si vous voulez.
Non, non, simplement, en principe, en conférence, on filme jamais les interprètes, c'est une règle internationale, on filme jamais les interprètes. Non, non, c'est rien de personnel,
Bien sûr.
Mais moi, c'est une norme internationale.
Excusez-moi, je me suis pas présenté aussi. Je fais un documentaire. On en reparlera.
Non, mais simplement, sachez, c'est rien contre vous.
J'ai bien compris.
C'est une règle internationale, on ne filme pas les interprètes en conférence. Voilà, c'est un truc qui a été établi il y a longtemps et on fait avec. Parce qu'on n'a pas, nous, on n'a pas le droit d'apparaître sur les réseaux, on n'a pas le droit d'apparaître. On est, en fait, nous, on n'existe pas. On est juste des voix et on entend des voix.
Okay.
Voilà,
et de dos, je pourrais utiliser si on ne voit pas vos visages.
Oui, mais après de dos, moi, le problème, c'est que j'ai ma calvitie. Thank you for your invitation. Sorry for not being with you. It's strange to be in a bit of a corner with just a screen, actually. And looking at myself. So what I want to do is come back to some of the elements which are key to understand the situation similar to what we experience, and elements which often are misunderstood or poorly understood, including by experts actually, and which are related to the fact that pandemics as the one we experience is a highly dynamic phenomenon, and there are interactions between elements that change constantly. Well, first one, the virus, which mutes or undergoes high-speed mutations. Didier Raoult said it as an introduction. You know, it's changing all the time. We're dealing with populations, highly diversified populations. I would say that's the basis of biology. We're never dealing with homogeneous static elements. We're dealing with complex populations which are highly diversified through mutations. The virus which is which undergoing mutations, and as Raoult said, we can see the virus, the dominating virus, but all mutants, all variants are there in the background, and this population of virus interacts permanently with host population. Human hosts are more stable. It's not like the viruses, population sizes, the cohorts, mutation speeds rates are not the same. But what changes rapidly in humans, and it is at this level that the interaction takes place, is the immune response. And the immune response are billions of cells which are in constant mutations to go with the virus through the mutation. We talk about immunity as if it is a stable set of virus, as it is the virus, but in fact we're dealing with population of cells from the immune system and population of viruses which are composed of billions of elements which are undergoing fast mutations and which are in interaction. So always look at things as a highly dynamic, unstable, complex systems with population that's changing all the time, and this is not the way it is understood. Unfortunately, to come back to the title of my presentation, I'll try to get some key elements. That is the base on the basis of the fundamentals of virology, poorly integrated by many, as we've seen. But we'll start from major principles. I will not invent anything. I'm taking what we teach in virology, or what I learned, and what I've been teaching ever since. 5 elements I'd like to come back to. First, I'll try to classify them, if you want, with key phrases. First key element, I'll call it, you're not asymptomatic by chance. Second element, a vaccine cannot do better than a cured infection. Third element, I mentioned it several times, Do not confuse immunity, I would say even immunities and immunology. Fourth element, we mentioned it as well, mutants are still here right from the beginning. They were from the very beginning. Fifth element, you will find only what you look for, and vice versa, if I could say so. We only search what we know and what we found before, more or less. So let me come back to the 5 elements. You're not asymptomatic by chance. Vaccine is never better than a cured infection. Immunity, immunology, mutants are still here, and you find only what you look for. And I will shed the light of the past and the way we understood these elements. First point. No one is asymptomatic by chance. Well, the major pandemics, deadly pandemics of the past, those are mainly the main, flus, which have been studied. When I was a student in virology, we talked a lot about the major pandemics. And we call them antigenic shift, means that major antigenic variation. The major flu pandemics, but it took place as well for coronaviruses, are linked to the introduction of a new virus into the population, and therefore the new dimension means that the immune systems are not up to date and mortality is high. Then systems are highly dynamic. That is, a high pandemic is highly deadly because of the newness of the virus, but immune systems update themselves, catch up, and after 1-2 years maximum, the virus circulates in a natural way. That was not observed in the past for the flu. When there is a major flu variation, flu is quite submitted to this because it tends to recombination. So there are recombination, reintroduction from animal reservoirs. The virus was never seen by the human population, and high mortality takes place. That was shown so for coronavirus in the past. For example, the Russian flu of 18-something was also a coronavirus, which at the beginning was very highly deadly, and then the immune systems of the population adapted themselves and mortality dropped. What it means, what it underlines, the story of the major pandemics to antigenic variations, what we also call the emergence or the advance, is that pathogenicity, the pathogenic potential of a virus, its ability to make you sick, is not due to the virus alone. The pathogenicity, the danger of viral infection, comes from not just a host virus, but it is the property of what we call the host virus relationship, the way the host manages the virus that makes it more or less dangerous. It's not the virus itself. Coronavirus, what makes a coronavirus benign coronavirus from a deadly coronavirus, it is first the immune response of the host. Someone who's already immune will not be sick, even though the virus is the same, whereas someone who is not will be sick. So we cannot say that the virus is deadly. They're all potentially deadly. In an immunodepressed patient, trivial infection, or someone with an active immunity, the virus can become deadly. So it's like a misleading word, it's a confusion of language. So do not consider the virus, but the system that will integrate the host. This is why I'd like to come back to a point at the beginning of the pandemic, when it happened. When it came out, we did not quite understand what was going on. There was mortality, fairly high mortality rate, and I immediately thought about those major antigenic variations and the large pandemics. But soon, a very disturbing element cropped up, that is, children were not touched. There was no mortality in children. It was observed right from the beginning, and we could ponder why. It was quite abnormal in a way, because usually when there is the advent of a new virus, we talked about dengue, about tuberculosis, or even major, the pandemics, children were not spared, young patients were not spared, sometimes they had reverse patterns. You know, the oldest one who had a flu variant who had a few decades before were protected, whereas the young ones had higher, well, expressed higher mortality. Though there was something highly abnormal and informative at the start of the COVID epidemics. That is the relative protection of children. And it was weird, it was odd. Soon, as a virologist, when you see that there is a high mortality with the virus, well, high mortality in part of the population and not in our segment, we can't say it's by chance. We look for the preliminary immunity in what built it, and rapidly it appeared that if young patients or subjects were, well, there are children and young patients. Well, if they were spared, actually fully spared, we checked rapidly in the first articles coming from China mainly, there were no death in children or even young patients up to 30 years of age. There were very few severe forms, or acute forms. It was quite surprising, and rapidly the simplest explanation that we've lost the sound. Sorry for the translation. We've lost the sound of the speaker. On a perdu l'orateur. Sorry. Well, it was endemic coronavirus. For me, those are forgotten in the understanding of the COVID epidemics. The four. Well, we know four of them. We discovered 4 strains at the time when we didn't have the detection means we have today. So most likely there are tens and tens of them, but dozens and dozens of them. But when coronaviruses were looked for in animals and men, we found them. So there are plenty of them. And today, the most simple hypothesis to explain the protection of children and young subjects is the existence of very active circulation of endemic coronaviruses from many strains coming from animals and others, and which also circulate in humans. So, protection of young subjects came from endemic coronaviruses. This was the most sound and simple hypothesis to explain this protection, and we ended up with a very conventional pattern where those who had already faced the virus were protected from the acute forms. Another element could be added to the infections or this reflection, what the infantile viruses, like smallpox and so on and so forth. So why do we? So we on all the infections there is a mortality curve or rate according to the age segment. Initial infections, primary infection, which take place in children, and then we see infections cropping up again. They are exceptional in young adults, and we see more severe other infections in 2 situations: either immunosuppressions, therapeutic or pathological, or the evolution with age. And in fact, in COVID, all of a sudden, we had some kind of a mix of 2 types of host-virus relationship, that of infantile virus hosting. There was infection before the age, so we had a pattern, or well, the endemic coronaviruses, which you had forgotten, circulates mainly in children. In children, they provide a form of immunity, and then this immunity, built in childhood, is lost with age, and the disease comes up after, let's say, 60 years of age. Very conventional pattern for Zuna, and then so on and so forth. So another element of infantile viruses, which is interesting with the COVID, was the fact that, as we said in the past, you better get it when you're a kid. Some of the disease you better get it when you're a kid. in young children, there are metabolic tissue immunological characteristics such that, healing, for example, or scarring, the tissue structure of organs are different in children, and therefore nature functions well. It's a good machine because viruses will infect young children, usually before 3 years of age. For the endemic coronavirus, at that age, children are not yet immunized, but they have tissue characteristics. Well, we mitigate the severity of the pathology of the disease, which takes place in a young age in children. But on the contrary, pathology is not severe at the time, but they become immune, and this immunity will last. So we can see it right from the beginning. We asked ourselves the question: all you had to do is look at the statistics, which were undiskutable, non-debatable. There was no pathology before the age of 60. There was a mixed pattern of infantile viruses with immunity gained in childhood, lost in time, which explained the mortality curve according to the age segment, mixed with an antigenic variation such that severity occurred earlier. So we are adding two factors of loss of immunity. The first one is age. Well, immunity drops in time, and the second is variation versus the original virus, such that it drops even more. So we add a pattern which was quite conventional, which was a combination of pandemics to high antigenic variation and infantile viruses, and we had a current representation, which we knew about infantile and what we knew about the. Can you hear me? Okay. So I've no return. I feel like I'm alone. We can hear you, Pierre. We can hear you. Good. Yeah. Keep going. So simple observation, as was said earlier on. Let's start by observing what we see. By observing the curve, mortality curve based on or age-based mortality curve, well, and by accepting the simple explanation that young subjects. Well, it's not a miracle. It's not because they're healthy, A child is not solid. It was acquired through preliminary immunization. So we have answers to three questions discussed initially. Well, the answers were about there. First is duration of the immunity. When we look statistically, and this is not debatable, there is no mortality between, let's say, 2 and, let's say, 55, 60 years of age. It's impossible to have a protection against severe forms of 2 to 65 years of age with a short duration immunity. It's not possible. So we knew there was a long duration immunity. Second element, this long duration immunity is mutation resistant, because if we consider that immunity was induced at what we called afterwards crossed immunity with endemic coronaviruses, there is a high variation between endemics and SARS-CoV-2, and basically, eventually this immunity is a protection despite the difference between viruses, and they will protect despite the variations. So, of course, this was a discourse which was called as reassuring, but when you see immunity which lasts between 2 and 60 years of age, which has been induced by a different virus, well, we should not panic because of potential variation of the virus or the duration of immunity. Those are two interesting elements. In terms of duration, we could talk about it a lot, this too could be said, but most likely when we got such a long duration, we know that for infantile disease, it's used to regular re-exposures because the virus is still circulating. If there is such a long immunity, it's not because you've been immunized once in life, it's because you are re-exposed permanently. And as we know, this is something we forgot, but we seem to have forgotten, but every winter we got a flu, we got a gastrointestinal problem. Means that a lot of viruses are fooling around, and those repeated infections will build and maintain immunity in the long term. Another element, most important, came out of the simple observation of the situation is that people between 2 and 60 were protected from the severe forms, but it did not stop the circulation of the virus. It is circulating all the time. Now, this is an important element, because if we are to add to this observation that people are protected from the severe forms, but not from transmission, that we add the second major principle that we've learned and repeated to our students in biology: a vaccine cannot do better than a cured infection. Well, we get the answer immediately that immunity may protect from severe forms, but not from transmission. So, at the time, it was at the beginning of COVID, it was discussed. For those who did not notice today, but it seems quite obvious, that immunity does not protect against transmission. The virus is still circulating. The only protection that we could target, that we need to have, but immunity cannot do better than to protect from severe forms. Today we can see it, when the vaccines are sufficiently designed, but it is illusory to think that in a respiratory virus like this one, to stop transmission. People who were at the beginning, we don't today, they talk about zero COVID or to eradicate the virus. It's not feasible on the basis of our current knowledge. Let me add another element. We can see that vaccine protects from severe forms. The vaccine, could vaccine? Well, the objective of vaccine is to protect against severe forms, but infection-acquired immunity protects from severe forms, but not from the transmission. So why? How come? Well, again, here, one key element to be understood is that, and that's the third point, do not confuse immunity and immunology. And today, do not confuse immunities, because often we talk about the immunity as if it was something like a solid block, quantitative and qualitatively homogeneous. As I was saying, if you look at the infection as a major choreography between billions of viruses, all different, billions of lymphocytes, all different, and we can see clearly that there can be only one interaction, and to describe this as a univocal, static and homogeneous system is ridiculous. And when I say immunities, there is something which is most important for respiratory viruses, is to make a distinction between what happened with the mucosa of the upper airways, in the nose basically, and what takes place in the lungs. In the nose airways, the virus is at the surface of the body, is outside in a way. Is there, is resident, but is not get into the body. So the immune defense line on the mucosa of the breathing airways is not very good, because the cytotoxic lymphocytes, don't go out. They stay inside. So they protect inside, but they don't protect outside. So the mucosa immunity has antiviral capabilities which are not the same as those that take place in the lungs, or where we can see during the COVID infection, there are massive infiltrate within the lungs. We can see in the MRI, there are just as many lymphocytes coming to clean up the virus. By the way, by doing so, they do a bit of damage in the lungs, and we don't have that on the mucosa. So you can understand that if the immunity protects better from the severe forms than from recurrent infections of the airways, it's simply because in the airways there is the immunity, it's very limited. So by using the PCR to measure the immunity, it is a major mistake to talk about immunity when you got something in the mucosa. When you've got immunity, when you got viral infection on the mucosa, it means there is no immunity. It doesn't tell you what's going to happen elsewhere. And when it comes to vaccination, if you do vaccination through a systemic pathway that would be inject in the shoulder. Now just imagine, and you think that you will follow the efficacy of the vaccine by PCR in the mucosa where there could be no immunity. It is totally absurd. I think there was cascading consequences as to the strategies, the way vaccinal performances were calculated or analyzed, but it's not the topic of the day, but it deserves some pondering. Anyway, first point, clearly there are immunities and they are not equivalent in different segments and tissues of the body, and this has several consequences. Then there is another key element. If we see the immune response and the virus as, if we consider that as a set of billions of viruses with billions of cells, it means that we have to see it as a race. We cannot measure the efficacy of antiviral immunity. Immunity is an clinical observation criterion. We are exposed to the virus and we are not necessarily sick, but immunology is a set of research and theories of analysis and experiments which try to report about the immune phenomenon, which is very old observation, showed that people who had been cured were not reinfected. So immunology was born from this reinfection immunity. This is why today, when we deny the established immunity, it's like rewriting immunology. Immunity is a clinical macroscopic phenomenon. Immunology is what is reporting about that. So when it comes to working on vaccine, this is a key element. I spent a few decades trying to develop a vaccine against the AIDS virus, HIV virus. It's not easy, Vaccinologist profession is complicated because on the one side you have to achieve vaccinal security, safety. We did vaccine in animal, in monkeys, or in apes, or in primates and cats, which were rejected because the side effects or adverse events were too severe. And if we had accepted a certain number of side effects, well, maybe we would have a vaccine against AIDS. But at the time, we were very demanding as to the vaccinal safety. So whenever developing a vaccine against AIDS, now how can we make sure that the vaccine works? The only way to be certain that it works would be to inject or to let people get exposed. In the case of AIDS, which is a 100% deadly disease, lethal disease before therapies, we would not ask people to get exposed or expose them or to inject them the virus. So, it was done in animals under specific conditions, but not in humans. So, of course, the only thing that we could do in practice during trials was to measure the immunological parameters, antibodies, but also cell responses. But clearly, at the time, we could say that the antibody measurements is not a measurement of the immunity. It measures the fact that something happened, as was mentioned, underlined by Jacques Fantini or Didier Raoult. The presence of antibodies is not a guarantee of protection. In some cases, the presence of antibodies is not necessarily good news. So the only way, well, let's not start saying, oh, there are antibodies, there is no antibodies. Well, to assert anything about the efficacy of a vaccine. So the measurement of antibodies is not a guarantee of vaccine performance. Likewise, the measurement of a PCR virus on mucosa where there is no immunity is not a guarantee of the efficacy of the vaccine. The only guarantee is this serious monitoring of serious forms in the body, and to my knowledge, due to the emergency of the vaccine development, this was not done in the state of the art.
And here's another important element. Because immunity is weaker than induced immunity within the body, because there is an interaction effect on viruses, and that is my fourth point, mutants are still around. As Diderot said it in its introduction, there are some collision species, which means that there's not one virus, there are viruses, and they're all different, and there are many mutations. So let's make a calculation. Within the viral population, all one-off mutations are here. They're already there within the population, and there are also double, triple mutations, virus that are here. But even if they're not here yet, they can develop really fast. So, as far as mutants are concerned, you can see that you can't sequence 1 billion viruses in one patient. You can only sequence the viruses that are already there, the dominant viruses. We can't see diversity, but if we could, we would see that all mutants are already there. So how can we calculate the proportion of viruses? Well, there's a selective nature of the virus. The virus mutates constantly. So if you take a specific population, it's very unsteady. Mutants are there, they stay there permanently, and the set of mutants is subjected to pressure, that is the capacity of different viruses to survive. So what about this? So it is a selective pressure. How can a virus within one patient, how come one virus will be more frequent within one body? So the enemy of the virus is the pressure, the selective pressure within time, and the main pressure is the immune response of the body. And there's a race going on. The virus can be blocked at some point is the immune response, and only viruses that have mutated can survive. So if the virus develops, the immune response adjusts to the viral mutation, and the virus keeps on changing and responds to immunity pressure. But there is also a more direct response, and that's the case with flu. The viruses that specializes in the so-called sanctuary areas, that is, the viruses are protected for the immune response, and the immune response tissues, the immunity response is weakened, the virus mutates. But if the virus manages to specialize and to adjust to survive in tissues where there's no immunity response, then the virus can survive. So there are sanctuary tissues, protective tissues, and among these areas, these so-called sanctuary areas, is the mucosa. So the more the immune response is spread within a population, the more the virus will disappear from the body. The virus will then adjust and specializes to replicate where immune response is weaker, and that is the mucosa. So you can see from these interactions that the stronger is the immune response of the population, the more the virus is searching for this so-called sanctuary. So the affinity with receptors and molecules that are abundant on mucosa will increase, and the epidemics will evolve. There will be an ever stronger immune response within the population, and then viruses will be less dangerous because they will hide in mucosa tissues. And that's why they won't develop severe forms. So the virus mutates, it's less dangerous because the immunity is there to face him, to restrict its movement in an area where there's no immunity. And there will be a sort of truce with the virus. The virus will stick with the mucosa. It will not, in exchange, the host will will remain undisturbed because the virus is in the mucosa, so it won't cause a lot of damage. As a consequence, some viruses get more contagious. So the objective of the virus is not to get more contagious, but it is a highly selective propriety. And once the virus is in the mucosa, it won't change. That's what happens with the Clint virus for coronaviruses, for example. Coronaviruses become specialized in mucosa replication. Mucosa for them is a paradise, and the virus won't get eaten by white blood cells or immune system lymphocytes. So they stay in these areas. They're still close to the outside world. So once the virus gets settled within a nose mucosa, it stays there. And that's what happened also with the stomach. So with a gastro problems, the virus stay there in this mucosa. They're still close to the outside world, and that's how they become very contagious. With time, the virus is less dangerous, is more contagious, and it is not due to a very weird connection between being contagious or being dangerous. They're just closer to the outside world. And that's what happens with AIDS and hepatitis. So let's take a virus that is in a liver, for example. This virus will be less contagious because it is not that easily accessible from the outside world as compared to a respiratory virus that can be transmitted through coughing or saliva. Can you conclude, please? As a conclusion, you can only find what you're looking for. That's my experience with AIDS. When AIDS occurred, when it first appeared, we were in the same situation as for the COVID pandemic, because we thought there was only one HIV virus, and then we realized there were many, that there were variants. That the virus didn't wait for the 80s to spread, that the virus was present everywhere in animals. So we analyzed all serums. There were all serums that were in contact with animals. And the origins of AIDS was considered an accident, as if a new virus had appeared by accident. So we realized that the virus wasn't new at all, that there wasn't one virus, but there were dozens of different strains mutating. We also realized that all great apes had been permanent reservoirs, that they'd been infected forever. And as regarding the structure of the HIV epidemic, there was an introduction of animal reservoir to human beings. The introduction of the virus wasn't unique. The virus was introduced from multiple ways, and it was mainly due to changes in ecosystems, changes in practices. There were two AIDS epidemics, the HIV-1 that started in Eastern Africa and then spread all around, and then there was a HIV-2 epidemic in West Africa. The epidemics followed the train railways as well as the vaccination rollouts in Africa. What I wanted to say that in the beginning we were looking for one virus. We found what we were looking for, and very soon we found new means of detection, and we realized there was a second HIV virus. Then we did some sequencing. We saw that there were many strains, and we realized that the virus would circulate non-stop, that it would be introduced from multiple sides. And if we apply the same approach to the coronavirus, we'll reach the same conclusions. At the moment, we wear masks, there's a lot of panic, there are exceptional measures, but there are also viruses that have always been there, and we haven't done that much to fight these viruses. So we need a targeted approach with high-risk people. What about those exceptional measures for the main population? Why do we do that for viruses? Why don't we do that for viruses that have always been there, with whom we've always lived, not in harmony, but in a balanced way? We need to think about it. We need to determine why we are radically changing what we know, what we've learned. I would like to thank everybody, and I would like to remember those who have taught me, those with whom I've worked. I've learned a lot from them. And I would like to dedicate this presentation to a virologist that died 2 years ago. That's called Jacques Debovich. He had a very pragmatic, very medical vision of the situation of the use of treatment. And to conclude with, I would like to remind you of one very important element we learned during the AIDS epidemics. Doctors can't discriminate patients. Infected patients can't be punished because they're sick. Patients must be cured. During the AIDS epidemic, some have called for punishing infected patients, and then the medical community raised their voice in unity to say that you shan't discriminate patients. Thank you very much. Et je traduis dessus, là.
Le son va régler. Si, non,
Je continue.
Ouais, faut continuer. Ouais, pardon.
Thank you very much. Your presentation underlined a very interesting element that can be connected with past epidemics. Thank you very much for this conclusion. I would like to join you in remembering Jacques Lebovich. He was a great researcher and doctor. He didn't have any bias or prejudice. He didn't hold prejudices, and I think it would have been hard for him to face this time, this era where there's a lot of discrimination. So this simple slogan is great. There's no discrimination in healthcare. As a unit, situation quite complicated for me because I'm right next to the computer. I will need to repeat all the questions to you.
Traduit tout, on traduit tout.
So you talked about the virus being in a mucosa. I apologize, there's no sound. Could you hear the question? Okay. No. So I was talking about super spreaders. Good morning, I am Claude Estrangel, microbiologist, and we've noticed that 20% of the population could infect 80% of newly contaminated patients. So can we make a connection between this observation and what you said about the colonization about the way that viruses colonize the nose area, or are there other mechanisms in place? Oh, I think that's enough already. There's one myth of the way COVID was handled, the way that asymptomatic patients contaminated the rest of the population. It can happen, but it is quite rare. So contamination happened with a high viral load. So the super spreaders are people with a high viral load in the mucosa. They don't have strong symptoms, but the symptoms mainly regard their nose. I don't think we need another mechanism to explain this phenomenon. I only think it is based about the viral load in nose. There are other mechanisms that come into play, but I think that the mucosa hypothesis is enough, and unfortunately we didn't draw enough conclusions on the matter. Thank you, Pierre. Pascal Mansa is about to ask you a question. I'm in front of the computer and I agree with you, Pierre, about the zero discrimination policy. This is a crucial point. And I would like to comment on what you said. Thank you for this very fresh and general view of the virologist and immunology situation. So you talked about the permanent immunity process. So you said that the immune response was a dynamic process, and we need to insist and underline the fact that once the virus is in the body, immune response will evolve within several months, several years. So it is quite important to take this into account, because we are talking about duration, about the boosters. So what we need to know is that at the beginning, immunity will evolve in time. It is crucial for preparing this immune response. The immune response will get stronger with time. You cannot stop it. You can undermine it, but it will still there, and immune defense will play a crucial role as boosters. So that's why children have a very efficient immune response, because they fight inflammation and their immunity improves with time. We need to stress this. So we're here at the AHU to discuss ideas, and as you know, there's one point I would like to promote, and I would love to discuss this with you at another occasion when we'll be maybe face to face. I would like to tell you that immunity is innate in the mucosa, and immunity adjusts. This adjusting immunity is not weak. It's not as weak as we think. And it is quite interesting to have your point of view on this matter. The mucosa is an organized system. The virus can get in, but mucosa strengthens the immune response. So let's not forget that we have an innate immunity that plays a crucial role in our immune system response. So I wanted to talk about the immunity of mucosa. There's adjusting immunity. There's a lot to say on the matter, and especially if we hear the point of view of immunologists and virologists. So thank you for this presentation. Thank you, Pascal. It reminds me of what we were taught at the Faculty of Medicine. We were told that there were no vaccine against colds. We were told that colds would repeat. There will always be a cold come. You will always catch different colds, several colds. But I would like to draw a connection with viruses. So viruses are here. They are on the mucosa. There are always viruses on the mucosa. And it's quite interesting because there's something never done in the past, that is carrying out PCR tests on mucosa of healthy patients. We had never dared do this in the past, but it showed that viruses are still there, they're always there. And if you carry out PCR test, you'll see that you have them, the viruses are there, so you do not get sick, but you catch the virus. That's what I discovered, that's what I understood. We always mention the exposure to children viruses that will maintain immunity in the long term, but could be PCR tests, large-scale PCR tests, show that viruses are always there. They live in our mucosa, just like digestive bacteria. It's their habitat, it's their ecosystem, and we're all infected permanently. So that's why it is quite absurd to try to eradicate the virus, or rather it's just quite unrealistic to hope you will destroy the virus. We have these reservoirs in our body. And as I said in my last point, you only find what you're looking for. So if you extend the specificities of the PCR test, but still carry out large-scale detection campaigns, if we keep on doing this, we would discover a huge viral diversity within the mucosa, and this diversity will go beyond all our expectations for all viruses, and including coronaviruses. So imagine if we carried out a large-scale detection test of resident viruses in the mucosa. Well, first of all, that would be really interesting, and we would see the whole COVID situation differently. It happens all the time. There are always viruses in our mucosa that leads to colds or other diseases. We live with viruses, and I don't think we realize how many viruses are there within our bodies, and most importantly that are always there. So just think about the fact that colds are dangerous. They kill people every year, but they also build our immunity. Are there any other questions? So can you kiss people on both cheeks to say hi? What do you suggest? How about kissing? Well, you should do what you want to do. You can't stop living. And I remember a sentence, what Didier Raoult said in the beginning. You can't lock up everyone because there's a virus circulating in the outside world. So if you get a cold during the winter, then you know how to avoid it. Just wash your hands, stay away from people, especially if you've got a cold but you're asymptomatic, so you don't want to hug everyone. But that's not, you won't isolate either, so there's no use in getting angry at people who do not wear masks. Can you hear me? Thank you for your presentation, first of all. I have a question. And I'll mention the Professor Milus, who created PCR test a long time ago. He received the Nobel Prize for this discovery. He died, which is quite ironic. He died from a pneumonia in August 2019, and before that he had repeated many times that PCR tests are not to be used to detect viruses. He said that PCR tests were there to detect fragments. So he said that if you wanted to find something, you would find it. So what do you think? What's your opinion about the fact that we use PCR tests to detect coronavirus? So what do you think about the use of amplification test? Amplification tests are a kind of a zooming copy mechanism. So you can do it as many times as you want, 45 times. So what happens is that you take this copy, take this picture of a mosquito, and you find you can zoom on it, like really. So what do you think about this amplification mechanism? It is quite an interesting question. It is also, I think we need to go back to good practices. A PCR test We're at the center of my works on the HIV virus. So I've worked at the INSERM since 2005, and now I create tests. And I have worked on PCR tests once upon a time. I mainly worked on cancers, and I do PCR tests for other purposes. So the basis of medical diagnosis is that tests are to be interpreted. It must be interpreted by biologists, by doctors according to specific criteria. So nowadays, the question is not whether we must use PCR tests with high magnification level. The question to be raised is that what does it mean? What do the results mean? Say the tool you mentioned is a good tool, but once you get the results, you need to interpret them. And as I said before, you can't lock up people because their PCR test is positive. It's meaningless. It doesn't make any sense. Secondly, PCR are done without, are considered as a warning, but sometimes they're carried out in healthy patients. Their test is positive because they carry a light, a moderate viral load. So we can use the data coming from PCR test. But instead of stating, of counting the cases of COVID, we can also say that a positive PCR shows that someone has a stronger immunity, and that with each case, the immune response, the population immunity is improving. So when you have a medical diagnosis, when you formulate a diagnosis, you cannot generalize the results. There are more technical considerations to do. We talk about false negative and false positive results, but in order to decide if a test is a false positive or a false negative, you need a reference, a standard situation to define what a false positive or negative is. So if you consider that, if you decide that clinical considerations are the basis of everything, then you get one conclusion, but there are many magnification cycles. So how can you decide if a test is a false positive? What I'm saying is that PCR tests are a great tool, but you need to know how to use it. You need to interpret it. You need to understand how it works. And today we do PCR tests with a high level of sensitivity, and which lead to hasty conclusions. But when we find a positive PCR test, we should take it as a sign that the patient is immunized instead of locking him up. Thank you, Pierre. We still have 1 or 2 minutes, so let me take the occasion to thank all the participants who have followed us online. And within the next minutes, we will hear from Robert Malone. He will be here in the IHU to make his presentation. So stay with us online. I think he will make a very interesting presentation. So 2 questions, Pierre. So first of all, listen to your presentation. I would love you to write a comparative study of the HIV and the SARS-CoV-2 epidemics. Second questions, we have all been expecting a second book. You have a book, you have written a book a few years ago. We're waiting for the second book. So are you planning to do so? So yes, it is true. I have co-written a book that was published in 2000. It was a critical an analysis of molecular biology. It was my specialty at the time. I was one of the pioneers in sequencing, and so this book was published in 2000. I promised there would be a second book, and I'm a little late. But I will start working on it as soon as I will have more time. I will retire, and I'll take the opportunity to write the second book. Many editors are waiting for it. It's really encouraging. Thank you. This is a standard reference for many students. So my first question was about an article that would compare both pandemics. Yes, I could actually write this article, but I am working. Sorry, the image got frozen.
On a perdu l'orateur.
Ok. Je vais aux toilettes.
Hein?
Oh, attends, je vais attendre la pause pour aller aux toilettes.
Yeah, I have to find a bit of time, you know, in my daily madness, but you know, great pleasure. Time for another question. Can we talk about cell immunity and what we have in the world? We found, do we have someone who had COVID and one COVID produced by cell immunity and led to, or is there, okay, on cell immunity question, that antibodies, does it protect possibly from severe forms? People who had COVID the first time and you know, 6 months to. So do we know a person who would have had a COVID crisis and then reinfection 6 months later and could have been protected from the severe form through cell immunity? Would not have been protected, sorry. Would not have been protected. Difficult to answer that question actually. From what we know today of the publications, all publications seem to say that reinfections, except for elderly patients, are less severe than the primary infections, but that's the first point. The reinfections are less severe, so there is a kind of immunity threshold. Then, to assign protection to one component of the immune response than another, it's very, very difficult. This is why we always talk, as I was saying initially, the immune response is a huge ballet, a huge choreography where everybody starts moving at the same time, but not in the same direction. You know, antibodies react from cell response and so on and so forth. So many players get in stage together. You know, some are innate, some are, you know, the basic element that triggers that. So billions of players come into action. So we tend to say, oh, you know, cell immunity and so on and so forth. But you know, each lymphocyte is acting. You know, we cannot classify them, but they all start playing at the same time. So to say that it is humoral or cell immunity, well, it's always difficult. So we talk about in vitro measurements of the in vivo protection. We talk about immune correlate. That is, we know that when we measure cell immunity in such a way, at such quantity with a well-set standardized method, we know that patients will be protected. So we can establish a link, a correlation between the presence of cell immunity, for example, actor, and protection, but that link is never a cause-effect relationship. It's difficult to say that it's only cellular or only humoral. It could be happen in specific pathology conditions when people are selective immunodeficiency, but in the practice it's very, very difficult to say. We know about the flu, for example, or respiratory crisis, you know, cell immunity is one of the critical and major elements of protection. But cell immunity in itself is kind of a blurry group of cell and lymphocyte populations, you know, cytotoxic lymphocytes, you know, there are, you know, antigen presenting cells and so on and so forth. It's a major choreography, very difficult to cut it into elements and assigning causality to each element. So that's why we measure in vitro correlate that make it possible to be predictive about the presence of a situation. But to establish such correlate, we need to have very serious clinical study or trial. You have to have a cohort of patients, not just a couple, you know, but sufficiently large cohort to measure certain parameters and to see if the presence of those parameters provide a significant correlation with certain level of protection during reinfections. Today, the development of standardized tests well set in the quantitative level or the statistic correlation with protection, this has not been established. We don't know. I would tend to be very systemic in the way I look at things. That is, I think immune response is this huge choreography, and this is choreography which protects us. So there is a second error. I will maybe take 1 minute to discuss that. You know, do not forget that vaccine or pre-existing immunity does not establish a barrier that will block virus. This is where sterilizing immunity does not exist. It's impossible. That is, even if you've been infected beforehand, what remains of the infection are not effectors. Effectors makes it possible to measure something that doesn't have a memory. The only thing that can actually, I do insist, that is capable of inducing immunity that could cure an infection is the infection itself. There remains some memory element related to infection or vaccination, and which will make it possible for the immune response to be deployed faster than when the infection. But what makes it possible for the immunity to reach a high level to get what we call the sterilizing immunization, that is immunity that will cleanse the virus, it's the infection itself. The inducer of healing immunity is always the infection, the virus itself, because of its quantity, because of its invasive dimension, will trigger and stimulate, will induce the multiplication of lymphocytes and immune response until it reaches a curing response. So at the time I would compare it to what we call a prey-predator relation. The lymphocyte is a predator, the virus is a prey. So we got the prey, the viruses, you know, population, and then the predators, and the predator will eat the prey. And by doing so, it multiplies. And therefore, we can see that, in fact, it is the virus that makes it possible in that image, that makes it possible, enables the T cells or the lymphocytes to multiply. What the vaccine does in preliminary immunization, it will leave a couple of predators in situ, and the predators will spread faster and will end the infection more rapidly by avoiding problems. But it's not because you've been immunized that you got a sort of an entry barrier. The curing of the infection is done by the immunity stimulated by the infection, not by the preliminary vaccination or healing from the past. This is a basic mistake. This is why very good vaccines, let's take poliomyelitis, for example, when you get vaccinated, you know, you get infected nevertheless. It is the infection that will reinduce the immunity at a level where it can block and cure the infection. And the difference is that once you've been vaccinated against, like, you know, there are a couple of predators who are still there, resident, memory response, that will ensure the curing response to expand rapidly before the sequelae are too severe. But you can see the infection is indispensable from the solid important immunity growth. This is why we say a vaccine cannot do better than a cured infection. It's the infection that induces the curing response. The vaccine is just getting it ready. This is a key element in the analysis, which is often forgotten. Thank you very much, Pierre, for those. Il est remarquablement clair, c'est brillant. C'est brillant, c'est très très clair. See you soon, talk to you soon. Thank you, Pierre. Bye bye. Non, non, mes micros, moi quand je fais ça ou quand je fais ça, mon micro, il n'y a plus rien. Ça, c'est une règle. Alors peut-être qu'après, ça vient de ça. C'est ça, c'est peut-être vient de ça. Mais nous, nos micros, quand ils sont coupés, il n'y a rien.
C'est un petit souci quand vous êtes passé de l'un à l'autre, mais après j'ai remis. Mais du coup, il y a quelqu'un qui a mis un message dans le chat.
Bon, alors qu'est-ce qu'ils font là? Il est arrivé, Malone, là?
Un mec en direct, c'est un anglais.
Oui, c'est bon.
Elle est là. Ok.
Real pleasure and a great honor to welcome Dr. Robert Malone. He's an eminent researcher, and he was, in fact, the first to mix fat particles with RNAs and to demonstrate that this mix could enter the cells and that the messenger RNA could be translated into a protein. And without Robert Malone, no RNA vaccine would exist today. So he's... Yeah, no. So,
no tomatoes.
No, it's a fact. Your PNAS paper in 1989.
Yeah,
I
that's
read
right.
it tonight
Yeah.
to present you.
Very simple paper.
Yeah, but very good. So you just have to switch here.
Okay.
Voilà.
So this is the advance?
Yeah.
Okay, good. So am I live?
Yes.
Okay. So thank you very much. I apologize for never being very good at French. I tried to learn French when I was a schoolboy, but I'm afraid that it would only embarrass me. I can say bonjour and merci, but when it gets beyond that, I lose it, and I certainly can't give a scientific talk. So thank you for the opportunity to visit you and to visit Marseille and to participate in the second International COVID Summit. I was very glad to participate in the first summit in Rome, which happened largely because of incredible efforts from two cousins, one of whom lives in Rome and one who lives in Toronto, and neither of whom are here right now, and both of whom have played a key role in enabling particularly the Paris part of this conference 2 days from now. Unfortunately, Lily cannot attend because the government of Canada has a requirement that you cannot get on an airplane unless you're vaccinated. And Lily has refused to get vaccinated, and so she can't be here, which I think is a great tragedy and sadness. But I thank you for the opportunity to be here and to speak to you. And I was asked about a topic, so I thought that it was appropriate for me to speak about the mRNA vaccines. And I'm afraid that this talk has components that are made for a general audience, because I think one of the things that we have as a problem is that there is this great fear that is throughout the population, and maybe it's been promoted. I think it has been promoted and weaponized by various governments. And part of that fear is the fear of the unknown. The RNA vaccine technology is often made to seem as if it is something special and a little bit intimidating, and it's made so it's hard for people to understand it. And so the main part of this talk is really aimed at average people, people who aren't necessarily scientists, and for them, understanding the central dogma of biology is important because we can't proceed with the talk. With this audience, I'm sure we all understand that DNA makes RNA and RNA makes protein, and we don't need to talk about that further. And so that's the purpose of this particular slide. I often give this presentation to physicians for training purposes. And even physicians, I find, unfortunately, I'm a little embarrassed, in the United States often don't really understand the fundamentals of molecular biology, which is a sad thing, and it says something about how we train our physicians, but we have to go through these things. And of course, as this audience understands, ribosomes are I use the metaphor when I try to teach about RNA vaccines and the technology of genetic vaccination, that these are like small biorobots that exist in the cytoplasm. I try to share the metaphor to help make this accessible to people, that we think of this process using the idea of the computer, so that the hard drive is akin to the genome, which resides within the nucleus. And then that hard drive transmits information out to the general apparatus in the cell through RNA, a particular type of RNA called messenger RNA, because people don't understand that this mRNA is just an acronym for messenger ribonucleic acid. So I have to explain these things. And that this message, this signal, which is kind of like a ticker tape in old or punch cards for people that are that old, when they think about computers, moves out into the cytoplasm, and then it gets loaded onto these biorobots that we call ribosomes that then produce the subsequent protein, which in the case of a vaccine is an antigen. And then I have to explain to the general audience, I think this is probably a pointer. Let's see if I can make it work. Yes. So I have to explain to the general audience what the spike protein is, and to relate that back to the virus and to the nature of the RNA vaccines that are being deployed, so that they can understand the toxicity and the mechanism of action. And so I have this slide talking about the nature of the virus in a very simplified way, that we have these spike proteins and their associated receptor binding domains that interact with ACE2 and are processed by TMP-RSS, and that this sits within the context of the virus. Of course, as you know, many people, there's a theory that viruses don't even exist, and this is actively promoted by various parts of the internet. And so I'm often having to speak about the fact that there actually are viruses, and that this virus actually exists, and this is the structure that it takes. Okay, now we get into the nuance that's a little more relevant for this audience. The mention was made that I was the first one to assemble this whole system of components and demonstrate that it could be used to transfer polynucleotides, RNA in this case, into cells. And then what wasn't mentioned was also I was the lead at the company called Vical for generating these RNA molecules, assembling them, and shipping them off to a laboratory that injected them into animals. And we found that these RNA complexes would actually be fairly effective in a relative sense. They were able to elicit protein expression in mice, in muscle, and actually we also were the first to demonstrate that protein expression could elicit an immune response in mice. And specifically, the experiments that were done that were in the original 9 patents that issued showed that we could use this system to express the envelope glycoprotein of Luc Montagnier's virus, LAV, which we now call HIV by a truce that was struck between Luc and Robert Gallo. I think it's important to, particularly here in France, to acknowledge the leading role that Institut Pasteur and the late Dr. Luc Montagnier played in this virus. So the initial proof of concept of the RNA vaccines was actually done expressing the HIV glycoprotein GP120 molecule, just to set the record. And that was approximately 1990, just for reference. Let's get a little bit into the formulation. And this matters for understanding some of the toxicities, which is the real focus of this talk. It's not just the mechanisms, but also the toxicity and understanding the science behind the toxicity. These are self-assembling particles. What that means is the polynucleotide is a polyanion, right? It's a long chain polyanion, technically. And these lipids are positively charged, as you'll see, and these days they're tertiary amines, which enables them to be pH sensitive in terms of their charge, whereas the compounds that I worked with back in the late 80s and early 90s, and then through the 90s in my own laboratory, were all quaternary amines. So they were permanently positively charged despite whatever the pH environment was. And this migration to a tertiary amine was important in enabling the current level of activity that is observed. And the group at University of British Columbia that has commercialized these in various ways, I think deserves much of the credit for the migration to the tertiary amine structure. You'll notice that the side chains on all these various cationic lipids have a variety of different structures, and some of them are non-metabolizable, and other ones can be readily hydrolyzed or metabolized in the cell. This is important in terms of understanding toxicity and persistence of these molecules. Understand that our cells normally do not have a cationic lipid, a positively charged lipid component in their outer or inner lamina. So these fusogenic cationic lipids are placing a novel lipid inserting into those cellular membranes. And these lipids convey a characteristic which normally cellular membranes don't have, which is being positively charged. But the problem that Phil Felgner and the group at Syntex solved was a long-standing problem, and I had been collaborating, for instance, with Judy White at UCSF, which was one of the liposome scientists. There was a very aggressive and productive laboratory group at UCSF that was working on liposomes, classical liposomes, and entrapping polynucleotides into classical liposomes. And that turns out to be incredibly inefficient, that process. And so the story that Phil Felgner, who is often credited with the original discoveries of the cationic lipid-based formulations, shared with me long, long ago in 1988, 1989, was that he was actually working on the development of lipids which would change the membrane charge on neural membranes, on nerve cell membranes. Fusogenic lipids that could be placed onto nerve cell membranes and change the charge to ask fundamental questions about neurobiology. And a rotation student from UC Davis, my alma mater, who had trained in the laboratory of Bolivar and Rodriguez. Some of you that are old enough, like me, may remember PBR322 plasmid, one of the early plasmids, and then the various M13, et cetera, vector systems that were developed by Bolivar and Rodriguez. And so this student that had trained with Bolivar and Rodriguez did a rotation at Syntex, which is just a few miles down the road in the San Francisco Bay Area, and found herself in Phil Fogner's lab. And the story that he told way back when, he doesn't tell it this way anymore, was that she came into the laboratory having worked with these plasmids, these bacterial plasmids, and suggested to him, well, these lipids are positively charged, these plasmids are negatively charged, what happens if we mix the two of them? And that apparently was the genesis of the breakthrough finding that you could have positively charged, in that case, quaternary amine-based lipids, and mix them. They would spontaneously assemble through electrostatic interactions with those polynucleotides and retain if they were formulated properly. And they were formulated together with other fusogenic lipids. Here we're talking about helper phospholipids as a generic for that, and such as DOPE, diallyl phosphatidylethynolamine, and other lipids that are known to be fusogenic. And you could cause these polynucleotides to slip into cells if you did this spontaneous assembly. And the lovely thing about it was that with the classic liposome technology, you end up throwing away 90+% of the polynucleotides because of the entrapment efficiency. It's extremely expensive, extremely inefficient, because polynucleotides are very expensive to manufacture. And these systems spontaneously associate, and you lose virtually none of the polynucleotide if you do it right. So that was the brilliant discovery that kind of set this whole thing in motion. Unfortunately, Syntex tried to make the RNA work, and what they hadn't done was all the heavy lifting that I had done before to understand the importance of the structure of the RNA and to enable large quantities of RNA to be manufactured using this new phage enzyme that had just recently begun available. I think it was through New England Biolabs, called T7 RNA polymerase, which is much more efficient than SP6. And then there was other sources of cap analog that could be incorporated. And I was aware of the importance of the 5' and 3' untranslated regions in ensuring that an RNA was appropriately translated. I used the elements from the Xenopus laevis beta-globin RNA, very stable RNA, and then the importance of the poly-A tail for ensuring stability. The Syntex group had not been aware of any of that and hadn't developed the manufacturing and purification process for large-scale RNA synthesis, which persists to this day. My friends that do this for a living, like at Aldevron, basically still use T7 RNA polymerase, cap analog incorporation, etc., and the same basic process, only it's scaled up much, much larger now. And so this is the, I guess it's Arcturus or Moderna and the group at University of British Columbia are busy having a fight over who owns the patents. But this is the basic fundamental structure of the ensuing lipid nanoparticle that's generated. And I think this one and this one are the more representative schematics. They're still grossly oversimplified, but we have polynucleotides that self-assemble with these cationic lipid particles, which then also self-assemble with the helper phospholipids and various other components that enhance membrane fluidity, such as cholesterol, is something I think we first published on in the mid-90s. And so one makes these mixtures of lipids, and the assertion is that by changing these side chains, one can change the tissue specificity of the resulting particle. That has been what's been put into the literature, and that's the basis for the assertion that these particles, we'll talk about in a minute, if injected into skeletal muscle, will hone to draining lymph nodes, particularly axillary lymph nodes. That was the thesis that was put forth to all the regulatory agencies, largely without strong data to support it. One of the problems with this whole field is that it's plagued by small, limited experiments, and investigators, they're very enthusiastic about their results, let's say. And so there's some bias in some of the data, And there's a variety of assertions about these various products and their specificities that haven't really withstood the test of time, particularly in humans. Now, there's another component here, and it's raised serious concerns on the part of many people, and there is a polyethylene glycol hypersensitivity. Why is the lipid PEG included in the final formulation is often a question. Because polyethylene glycol historically in liposomology has been used to create what the technical term is stealth liposomes. These are liposomes that can be injected, and if they are appropriately coated with polyethylene glycol through a variety of different mechanisms, they will largely escape clearance by the Kupffer cells of the liver. So polyethylene glycol basically creates a structured water shell, if I can use those terms to this audience, if you understand. So PEG basically structures the water almost in an ice-like structure, but it's kind of slippery. So you have structured water around this that's structured by the PEG. Why is that important? These particles have a strong tendency to self-assemble and associate to form large aggregates. It's one of the main problems with this tech. There's a number of problems with the tech, but in terms of the fundamental formulations, one of the things that's been problematic ever since we did those original studies is that you'll make these formulations and then they'll fall out of solution. They'll flocculate fairly quickly in the span of minutes to half an hour at room temperature, which is why it's super important after you rehydrate these in the clinical context that those formulations are administered as soon as possible because they will self-aggregate. The reason why the polyethylene glycol is included in these formulations, and these are polyethylene glycol molecules that have relatively short acyl side chains. So they're engineered to not stay in the particle. They are engineered through these short side chains so that when they're administered, the polyethylene glycol component rapidly disassociates because it will interfere with the ability of the particle to fuse and find its membrane target. So the problem with that is that people that have hypersensitivity to polyethylene glycol, suddenly they have free PEG with short acyl side chains floating around in their body with a very short time course, and that can be associated with anaphylactic reactions in some of our patients. So that's part of what drives the short-term anaphylaxis. But the reason why the PEG is there is because if it's not there, then as soon as you hydrate these particles after they've been prepared, these will aggregate and you'll end up with flocculation and very large particle sizes that we don't want to have administered into our patients and that are not effective in terms of the transfection activity. So those are the components. As I mentioned, these different lipids are asserted by various laboratories to confer different specificity. Yeah, acuitas, that's the current term, from the University of British Columbia group, which rumor has it, by the way, the Trudeau family is a major investor. Good to know. So they self-assemble. This is a gross oversimplification, but now you have a basic understanding of the relationship between the RNA, the cationic component that self-assembles with it, and some of the other components that go into the final formulation. And then I've mentioned briefly about the importance of the various structural elements of the RNA and the overall manufacturing process, which in my hands did not include pseudouridine. Okay, pseudouridine incorporation is something that was brought into this system by Carrico and Weissman, and we'll talk about that a little bit later. Like right now. First time I've given this part of this talk. So pseudouridine, as you can see, is a modification of the base component of uridine, typically catalyzed by pseudouridine synthetase, and there's various versions of that in the cell. And the assertion was by Carrico and Weissman that the incorporation of pseudouridine was critical for inhibiting the inflammatory response that's generated when you inject these lipid nanoparticles. I can tell you that in my lab through the 90s, working with animal models, we tried so many different lipid structures. We had chemists involved, so many different formulations in animals. They are incredibly potent at eliciting an acute inflammatory response in our hands. I mean, you can put this stuff into a monkey lung and you'll basically have a neutrophil infiltrate like you've never seen before. They're very, very potent at eliciting an acute inflammatory response that is polymorphonuclear dominant. And Carrico and Weissman asserted, based on their findings, that the incorporation of pseudouridine will overcome this inflammatory response because they observed, and it was already known in the literature, that pseudouridine placed within an RNA will make that RNA hypoinflammatory. Now, I'm going to share some words with you. One person's suppression of acute inflammatory response is another person's immunosuppression. Okay? It's a question of how we use the words. It's the same phenomena. So the random incorporation of pseudouridine appears to not only suppress the hyperinflammatory response that's associated with the cationic lipid formulations, but it also appears to be suppressing, in a more broad sense, other particularly T cell functions. That kind of turns out to be important now that we get into the clinic. Oh, I only have 5 minutes. Okay, I better quick. So pseudouridine facts. Pseudouridine may control mRNA metabolism, and it appears to affect many facets of RNA function. And most importantly, it abolishes a lot of these responses that are associated with adaptive inflammatory responses. This gives rise, it appears, to this observation of an acquired immunodeficiency syndrome, which is associated with multiple vaccinations and is emerging in our patients. Often people misunderstand the idea of this AIDS-like syndrome. They interpret it as being due to HIV or LAV, when in fact it is an acquired immunodeficiency syndrome. And we know that that's occurring because we see the reactivation of DNA viruses. And we also appear to be seeing cancer incidence rising and the aggression of certain cancers being very different. I mentioned the thesis that these things go to draining lymph nodes. Unfortunately, we now know from the data that they are not restricted and they go all over the body. And we know from the Pfizer data that the lipid component accumulates in ovaries, among other things. This is another important paper. Unfortunately, this should have been done before it was ever administered to humans. And this key paper buried within it has a number of observations. Basically, we have higher levels of spike protein being generated after the RNA vaccination than one obtains in systemic levels of spike protein than one observes after natural infection. It persists for a longer period of time. And what was most surprising to me with this paper is the demonstration. This is not a cell culture experiment like the recombination in HepG2 cells. This is from lymph node biopsies, fine needle aspirations in humans after RNA injection, and the RNAs persist for at least 60 days. That gets back to the pseudouridine story. Random incorporation of pseudouridine. Pseudouridine, that we now know, has to be is very carefully controlled in the cell. It controls RNA stability and RNA metabolism. What we're doing with the random synthesis with T7 RNA polymerase is we're incorporating pseudouridine all over in the RNA, and it appears to be generating RNAs that are extremely long half-life. They don't seem to be getting degraded the normal way, and they're associated with extremely high levels of spike protein being produced, which, I'm sorry, fact checkers, is a toxin. Now I've run out of time. You all understand the fundamentals of immunology and activation. You understand the processes of antigen presentation and both 4 and 8s, CD4s and 8s, and the generation of memory cells, which is really what matters, is the memory cell response, not the presence or absence of the neutralizing antibodies. I'm not aware of any data that validates, quote, neutralizing antibody titers as a correlate of protection for these vaccines. You know that the spike protein is basically the engineered spike that, in my mind, came out of the Wuhan lab, with the one exception of the 2-point mutations in the S2 region to make it more immunogenic. But otherwise, the functionality that was engineered remains in the vaccines. This is just to share with the average audience about the molecular size of spike compared to the blocking antibodies, and the importance of the different domains in blocking antibodies, and the fundamentals of T-cell immunity, and the fact that all of us have already been exposed to common cold coronaviruses and already had strong baseline T responses that often were able to be reactivated. We've seen that. That's why you see the immune responses coming up in 14 days or less with these neutralizing, quote, neutralizing antibodies, is because a lot of those are actually recall responses. And given the interest of time, what are the risks, which is what I wanted to talk about. We now have in the States, consequent to court action, the FDA tried to hide this information. They were going to withhold it for many, many years until all of us essentially would be dead. But the courts in the United States have forced it to be disclosed. This is part of a initial, I think it's 57,000. It's a huge number of pages. But there's one table in particular that I'm focusing on here that lists the cumulative adverse events detected by Pfizer-BioNTech for their post-marketing vigilance. This is just a graph of the incidence of different types of adverse events observed from their data. And I'm going to quickly go through this. You ask, what are the adverse events associated with these vaccines? Here's page 1, page 2, 3, 4, 5, 6, 7, 8, and 9 pages of adverse events associated with these vaccines that we've all been told are safe and effective. And so in the interest of time, I thank you very much. I'm sorry if I've run over. I hope that was helpful, and I hope you now kind of all understand the fundamentals of the technology and some aspects of why it has gone awry. And I think the one that has really been neglected is a recognition of the importance of pseudouridine in some of these phenomena, such as the immunosuppression and the extremely long half-life, which is in contrast to what the pharmaceutical companies have been asserting, that these RNAs, after injected in our patients, only last for a couple of hours. That's clearly false. Thank you for your time.
Thank you very much for this brilliant talk and to give us the opportunity to understand really what is the rationale and what is the scientific background for those vaccines. I'm sure that there are many questions.
Don't be shy. Even though I can't speak French, I won't criticize
You want me to speak French?
I cannot. I apologize.
No, sorry. Regarding your experience, for you, how long lasts the mRNA in the cell after the injection?
So it's typically, so I did do some time courses in the original PNAS paper, but that's a different delivery system, and that was only in 3T3 cells, although I did test every cell line I could get in the Salk Institute, but I didn't do time courses. They appeared, the original structures that we were making without the pseudouridine seemed to last for about an hour or two. And you can tell that empirically by looking at the kinetics of the protein production, which essentially approach an asymptote. And so, of course, we have a range of stability of the RNA, but that it seems to hit that asymptote at something like 2 hours.
Thank you.
By the way, the firm CureVac does not use the pseudouridine, and there was assertions that the CureVac product didn't work, but in fact, the CureVac product was at a significantly lower dose, and in retrospect, they got less than 50% seroconversion. But now what we see is the true data that's coming out even with the pseudouridine is really not that strong. And so I think if CureVac had the opportunity to go back in with a higher dose, I'm not convinced that the pseudouridine is necessary. If I had an opportunity to work with a team in Europe, I think the CureVac approach is probably going to be safer, I hope. But that's somebody else's business, not mine. Yes, sir.
Okay. Can you give us your opinion about what is maybe a major risk, which is the quantity of spike produced during an injection, which is probably an individual response?
So the quantity of spike produced, I reference this Cell paper, so I rushed over it. But I prefer, rather than to give my opinion, to refer to actual data. And so these are data on the levels. Let's see, spike protein was detected in plasma of 96% of vaccinees at 47 picograms per mil, and 63% on day 7 at 11 and 1.7 picograms per mil. When I first saw these data about the spike level, the first time I became aware, and this is a time course, obviously, in humans from both plasma, from blood sampling, there was an earlier publication out of Brigham and Women's Hospital very early in the outbreak that looked at the time course and levels of protein in nurses that had received vaccine. When I went through and did the calculations, I was stunned by the level of spike protein. It's down in the picogram levels, but as somebody who spent a good part of their life working on these systems, getting that level of expression in a mammal, remembering that that's detecting the free protein, and you have spike that is cell-associated, intracellular, binding to ACE2, all this is measuring is the free spike, which is in equilibrium with all those other forms. It's, in my mind, this is a stunningly high level of protein. I mean, in a sense, it's an amazing success story in terms of the fundamentals of what Peter Cullis and company did, the fundamentals of actually getting protein made from a transgenic system after an injection in humans, I think is amazing. But in terms of spike, I've been fact-checked both ways to Sunday that spike is not a toxin. But as far as I'm concerned, a toxin is as a toxin does. And as far as I'm concerned, the data are quite clear that there are a number of toxicities associated with circulating spike, not the least of which is binding to platelets and generating an autoimmune condition that we call thrombocytic thrombocytopenia, thrombotic thrombocytopenia. So I hope I've answered your question.
What is the part of side effect which could be due to the lipid nanoparticles? You mentioned the spike,
yeah,
but there are also the
so
lipid nanoparticles.
precisely, thank you. And here's what I can say to that. Because the data, this is another one of those stunning things that wasn't done, right? Why did the regulatory authorities totally bypass all the norms in terms of pharmacotoxicology and pharmacokinetics and pharmacodistribution? I have no explanation for that. It's one of the things that I find most aggravating about this, is the lack of following pharmaceutical norms in preclinical and clinical studies. So Moderna is pursuing I try to stay with the data, and so I have to give stories because I have to give context to the data, okay, so forgive me. And I talk too much. But Moderna is developing a RNA vaccine-based influenza vaccine product. They seek to market an influenza, and ideally a universal influenza vaccine product. I spent a good part of my career chasing that beast too. Good luck. But they released data from their phase 1 studies on their, and I don't have that data here, I've presented it elsewhere. They released data on the toxicities in the clinic in phase 1 of their influenza RNA-based vaccines. They only released this data to their shareholders. Fortunately, I had a shareholder that did screen grabs and sent me some of those slides. It turns out that at the 100 microgram level, which is the dose that they're using with us, that I took and had adverse events with Moderna for the Spikevax, it turns out that at 100 microgram level, 90% of the patients had adverse events as compared to about 30% in the control group with the influenza vaccine. That tells us that there's a strong adverse event profile associated with the lipids themselves. But these are small numbers because it's a phase 1 study. But it clearly demonstrates that there is intrinsic toxicity which exists outside of the spike protein itself. We have the limited biodistribution data, non-GLP, from the Pfizer Common Technical Document that Byron Bridle obtained from the Japanese CTD that demonstrates this odd distribution of the lipids, including to ovaries. And we have the clinical findings that women know and was long denied, that we have these alterations in menses and other reproductive health consequences that seem to be associated with these. So we have two phenomena, and those, as this audience knows, the thing that controls menstruation is the ovary. So we know that we have, and the ovary is reasonably likely to be very sensitive to charge environment in its membranes. So we know that these lipids have an odd predilection for ovarian tissue. We know that the complexes upon injection are associated with dysmenorrhea and menometrorrhagia and other phenomena that seem to be affecting women's health that were long denied, but women all over the world reported. So I think it's reasonable to infer that there is lipid-based toxicities, number one, based on the Moderna influenza vaccine studies, and number two, that some of those toxicities involve ovarian function.
Maybe just one for me. I did not really get the point of shifting from quaternary amines to tertiary amines, because at pH 7, both are charged positively.
And it appears to have to do with the acidification of the endosome.
Ah, okay.
And so,
Okay.
right?
That's an answer.
Okay.
Perfect. Voilà.
Okay, thank you. Let's have lunch.
I have managed a meeting with Didier out
Oh, super.
in a few minutes.
I just wanted to say hello to him and give him a hug.
So
I don't know if he's a hugging kind of a guy, but I know he's been through
is the genomes of patients tested here with different technologies that we use. The first cases were diagnosed in February 2020, and straight away we sequenced the genome through two approaches: the nanopore technology that let us test the genome in one day. Furthermore, we used technologies that aim to to use electronic microscopes really fast. So we used sequencing technology called Illumina or nanopore. So there are different sequencing machines so there are different sequencing machines for the nanopore technology. So that was in February 2020 until the quarter number 1 in 2021, and from April 2021 we have used the Novasec sequencing machine, and from 2020 we have done sequencing at the national level, and we joined the Emergen consortium that has been financed by the government. But beyond genomic sequencing, we implemented different PCR variant-specific PCR tests with really low viral load, so we can determine that they've been affected by a specific variant. So that's really helpful if used alongside genotype characterization. So you can see here from February 2020, different genotypes have been determined through a high level. So we have used the PCR technology, and we have used different technologies that have been recommended ever since, so high-rate sequencing. And we got genomic genotypes that have been classified through online tools that are very useful. There's Nextclay, there is Pangolin, they all have their own classifications, and variants have been communicated from the for the occurrence of the British variants, but we had detected the first variant in July 2020, the summer before its occurrence, and we had developed our own system of classification, and we had defined a variant as being a group of genomes of about 30 genomes with at least 5 specific mutations in the genomes. If you take the 10 first variants detected during the summer 2020, and you can see all along the genome, you can find different mutations at specific position that enable us to classify the genomes, to classify them as belonging to a specific variant. There are also practical variations that are analyzed in order to determine which variants they belong to. So we have detected 12 variants during in the summer 2020 at the IHU. We also detected other variants after that. In total, we have studied the case of 57,000 patients, and as you can see, 14,000 patients have the Delta variant, 11,000 had the Marseille 4 variants, 10,000 for the Omicron BA1, and lately the second type of Omicron variant. So we will talk about each of them, but first of all let me talk about the variations and mutations of the virus. There are 2 main mechanisms typical for the RNA vaccine, which can be linked to polymerase errors that will induce mutations, that is, changes in a nucleotide, and these changes can affect the amino acid, as you can see, with different colors. So as the virus replicates, and it will accumulate different mutations. So SARS-CoV-2 and coronaviruses have the same particularities. They have a protein that can correct mistakes, errors, but not all errors are being corrected. And secondly, there is a genetic recombination, but we'll tackle this a little later. So if we sum up everything we've observed in SARS-CoV-2, there are 2 mutations by genome by months in average. And if viruses were to be represented by colors, while it replicates within one body, you can see that some variants or mutants will appear, and some of them will be selected through different selection process. The selection process, there is a selective pressure within the bodies, and there will be some polymerase inhibitors that will apply pressure, or vaccines that will also exert pressure and select a variant over another. This graph shows all genome sequences of all the variants that have been of the SARS-CoV-2 variants. So there you can see the number, the average number of mutations within the genome, and as time goes by, this number increases. So that shows there is an accumulation and mutation with time, and this is a general mechanism for RNA virus genomes. It works for Ebola, for dengue, for measles, and others, and so on. Since summer 2020, we have detected different several variants. So that is genomes that are significantly different from other genomes. There were some mutants here in France, as you can see, and then we have in different colors different epidemics, and each color represents one variant. Some variants circulated, so there are some circulating periods that overlap. There are some co-circulating periods, and as you can see, so each variant is linked to a different epidemics, and in the end there is no there's no rebound. The virus didn't rebound. It's just that new variants appeared and generated new epidemics, and if you combine them, you get the total incidence of cases. So here's the same graph but presented differently. This is a 3D representation of the same graph. You can see different several variants with a bell-shaped curve for each of them. And now I will tell you about the emergence of variants detected in Marseille, and some of them have had a pandemic circulation at the international level. So the first variant we detected, it was in summer 2020 in July. We called it Marseille 1, and we analyzed the sequence of this variant. It probably originated from West Africa, and it had been reintroduced in France during the summer 2020, and it had been reintroduced through shipping, through passengers that traveled by boat. That's people that traveled from Marseille into North Africa, and these passengers were infected by this variant. Then this variant remained epidemic within the region and did a spread outside of it. These are other examples of variants introduced in France from abroad. There were variants from South Africa. There's one variant from South Africa. We showed it had been introduced in Marseille from Comoros Island. There's also the Delta variant that comes from India, and the two first cases we detected were with a tourist that went to the Maldives island that came back to Marseille, and there's also Marines that came to Marseille to get on a ship that came from India. And recently, we detected 15 cases of the IHU variant. It remained concentrated in the region. It is not a pandemic variant. It is only an epidemic variant. Jacques Fontini analyzed the spike protein, as you can see. Recently, the Omicron BA.1 variant was introduced. The first case was detected in a patient that came back from South Africa. We worked with Jacques Fontini on this. The BA.2 Omicron variant was introduced in the same way. The two first cases were detected in two patients, in two people that had traveled to Tanzania that came back with this Omicron BA.2 variant. In total, different variants were introduced to Marseille from abroad. So these variants overcame the frontier and they created the emergence of the variants. The first variant was a mutant, it came from Italy. It is derived from the Wuhan virus. So this is my colleague who made this animation. And there was the Marseille 1 variant, possibly coming from West Africa with a strong connection to Algeria. Then came the Marseille 2 variant that possibly comes from Spain. It spread in Europe from Spain. Then there was the English variant. The first cases were detected in people coming from London by chance, and then there came the variant from South Africa. There was another one that possibly originated from Guinea, another from Nigeria, others from India, as I mentioned before. Another variant came from the Maldives, and there was also a rare variant that didn't become pandemic. It came from Colombia, and the first case was detected in a child whose family was from Colombia. So this is not the only way variants can emerge, variants that have been detected. And between August 2020 and February 2021, the predominant variant was called Marseille 4. It was first detected in July 2020. And there is evidence that it could originate from mink farms, and there are several arguments to support this hypothesis. Minks are reservoirs. We know that SARS-CoV-2 can be transmitted from minks to humans. It has been demonstrated in Denmark, and then we got a time-based evidence, because there are mink farms in France, and when the epidemic resumed in France in July 2020, it started in an area that is close to a mink farm, and this is where we found cases, and then the incidence rate went up on the whole territory, but the first human cases were found in around this mink farm. So that was August 2020. It was the summer, the holidays, so people came to visit Marseille. They were infected, they had COVID, and we had obtained a genome. We had collected a genome from a French mink farm in November 2020, and this genome was only detected in March 2020. It was at the middle, at the center of the genome of the Marseille 4 variant. Furthermore, this genome was found in this mink farm. All the genomes we found in this farm were Marseille 4 variants. And in March 2020, if we look at the sequence, that we have in our database, then you can see there are some sequencing coming from mink farms in Poland. These genomes match some Indian variants genomes. There are other matches between mink farms and British variants, and we also have sequences originating from another Marseille variant Marseille 2, that has been circulating in Europe. So we need to consider these zoo genomes because the virus is still active in minks at the moment. So we took these genomes and we tried to detect everything, any abnormality, anything rare that could point to new variants. We also analyzed genomes that whose profile made us think that they could have a different phenotypic behavior. So we tried to analyze genomic differences. We analyzed samples. And Professor Escola has analyzed 6,000 strains of the virus, and we also tried to run other tests. So there was a genome that was found in many variants, such as the Delta variants, and so the variant had this mutation, but we found it in another lineage. We also showed that there was some converging evolution, which means that even if a mutation of the same position in the genome, it could happen into different, very different lineages, which lets us make us think that it provides an evolutionary edge. We also studied patients that had SARS-CoV-2, that had a chronic form of the SARS-CoV-2 that were affected over several months, and it was caused by their immunosuppression. So here's a few examples taken from literature with patients infected for up to 100 days, and we had a patient that was infected for 110 days. There were also many mutations, up to 40 mutations over the follow-up period, which is a lot, which can be caused by treatments that were given to these patients. So there are also patients that had SARS-CoV-2 that were cured or that had specific antibodies. So it is really important to analyze genomes to detect reinfections, meaning patients that were infected, that were cured, and that got infected again 90 days later. A first case was detected in the fall 2020. And in the beginning of 2021, we had already detected over 50 cases of reinfections. The rate was 0.6%. That was the reinfection rate, and this goes up with the Omicron variant. So each variant determines a specific epidemic. And regarding the Marseille 4 variant linked to the mink farm, we noted that it had a double bell-shaped curve, and with phylogeny, we noticed that there were two groups of genomes called subvariants, and within this variant, they were 20 different lineages, and each lineage had an independent evolution development, and that's how we determine different variants with bell-shaped curves. We focus on this specific subvariant called Marseille 4 that had emerged at the end of 2020, and it had been associated with the resurgence of incidence. So there were different lineages within variants, and after the accumulation of 7 and 8 mutations, the lineages would disappear. And we also showed that there were mutations connected to the occurrence of a new lineage, of a new variant, and we also observed that there was a specific element that made the protein inactivated, and that was linked to the subvariant Marseille 4. And we obtained this result by comparing clinical data, and we found it was more virulent than the previous variant. And here we have other data coming from genomics with new variants, with atypic genomes. This data come from Bernard Escola, and thanks to this data we analyzed the phenotypic characteristic of the variants, and this shows that the patients that were previously affected by beta or Marseille 4 variants showed lower infections, and there is a difference between vaccinated people and unvaccinated people. So as you can see on the chart, there are all the different variants that are shown. There are also differences in the serology of people vaccinated with Pfizer or AstraZeneca vaccines. And this also shows that variants have a different behaviors for cell tropism, which means that variants can infect viral E6 cells. They have the same capacities for infecting intestinal cells, but there's a difference with Cu3 cells. As you can see, the blue bars, there are great differences between variants. And this data was published recently. It's data about the B1 Omicron variants, and it shows that it can escape, it can survive. So there's a really high neutralizing power of this variant, Omicron. We also have data, genomic data, for classifying variants that shows that viral loads are different depending on the variant concerned and depending on the period of the study, because variants weren't studied at the same time. So this is the Delta variant and the Beta variants. So we can cultivate variants, and there are differences with viral loads depending on the variants. To conclude, we have made associations with different genotypes, and we also feel that there has been a decrease of the clinical observations with time, and we have noted that infections were less severe with specific variants as compared to what we've observed with Marseille 4 and Marseille 2 variants that came before them during the pandemic. And there was also a lower rate of hospitalization with the Alpha variant as compared to what we observed with the variants coming from the mutants of the Chinese virus or the Marseille 4 variants. And to conclude, I'd like to talk about recombinants. So you probably heard about them. So beyond genome variability, there's another mechanism for genetic variation with recombinants. It happens quite often with RNA. So at first you need a virus with a first variant, for example. This variant will lead to an infection, and there will be another variant that can circulate and produce a co-infection. So if these two viruses are in a patient at the same time, they can find themselves in the same cell, in the same respiratory cell, and that's how you get a recombination. You can similar recombinations, which means that the genome will get a mix. There will be hybrid genomes being produced. So as you can see, there are two parental variants. They have the same color, but then there is a recombination because the same cell is infected by two different variants, and that's how you get the recombination phenomenon, and you get this mixed genome. So that could happen actually, because there was a recombination of of several variants, the Delta and Omicron, Omicron and BA2, and so on. So here's a few examples of recombinants that have been detected. So here is the genome, a MARSEI-4 genome that infected a patient in December 2020. He was immunosuppressed, this patient, so he remained infected by the virus, and he was over-infected by another virus that was an alpha variant, the English variant. And so you can see it here represented in yellow, and with time, hybrid have appeared. So the green areas refer to MARSEI-4 or alpha, and so the areas can be connected to MARSEI-4, and other areas are connected to the alpha variant. So in total, we got a hybrid variant, alpha MARSEI-4. We've cultivated it based on 20,000 respiratory samples, and we found this recombination of variants. Here's a second example with the combination of the Delta and Omicron variant. This is the recombination of the Delta variant and the BA1 Omicron variant. So the spike protein became Omicron BA1, and the rest of the genome remained in the Delta variant. Recombinant variants are to be found more and more often, because to detect them, to identify them when we analyze genomes, we need all these bars, all these mutations. If there are no mutations, if there are only 10 mutations on the genome, you cannot see if there are recombinations or not. And since there are about 65 mutations for Omicron, they're usually really close to each other. So when we get this, we can shed the light on recombination elements. And so this is, we have started to write about this recombination of variants. And that's it. So coming back to the Delta Omicron variant, we have observed it through the microscopes. We have cultivated it, and we obtained an analysis of this variant that behaved like the Omicron BA1 variant as for the spike protein. In conclusion, there's a high mutation rate for SARS-CoV-2. They're spontaneous. It is quite difficult to predict the mutations of SARS-CoV-2, and beyond mutations through polymerase errors, we can now detect it, and as you can see, each variant has led to different epidemics. Many of these variants have been introduced by crossing borders. We talked about variants coming from in our region, but they came from all over the world. So they have zoonotic reservoir like minks. So we need genomic monitoring. We need to monitor genotypes, and we need to understand a whole genome sequencing so that we can have the whole picture and connect it with a patient treatment if possible. Thank you.
You showed that the main factor that would explain the variance was human disease.
Non,
c'est plus compliqué à mettre en évidence. En tout cas, il n'y a pas vraiment d'évidence très claire. Ce qu'on voit effectivement chez des patients qui sont chroniquement infectés, hein, c'est qu'ils reçoivent souvent de façon concomitante différents traitements de manière à essayer d'éliminer le virus, mais on voit bien que ça ne marche pas. Et peut-être que ça contribue en fait à sélectionner. Ça, sur la base théorique, c'est tout à fait possible. Après, le niveau d'évidence n'est pas très important à ma connaissance encore.
Merci. Est-ce qu'il y a des questions? Oui.
Je voulais savoir si le niveau BA2, le Omicron, il est associé à des résultats cliniques pires ou pas pires que le BA1. Parce qu'on voit passer ça dans la littérature, d'après la littérature, des médecins qui sonnent l'alarme. Est-ce que c'est une alarme fondée?
Non, je crois que en fait ici, je parle sous le contrôle de Mathieu Millon, qui est clinicien. Le comportement, en fait, le phénotype clinique, hein, la présentation et l'évolution clinique des patients infectés par le Omicron BA2 est assez proche de celle des patients infectés par le variant Omicron BA1 pour l'instant.
Patient. Pareil, question muette, UKID, UKIDA. Ils servent à quoi les micros de salle parce qu'on n'entend rien là?
J'ai pas de... Les micros ils servent pour mon enregistrement, mais pas pour...
Ah d'accord. Yeah, clearly the immune system selection pressure it plays a role. Now, how much and how it can orient the process, that's difficult to say based on data available, but to quantify it or to characterize it in a precise manner. C'est ton copain ça?
Ça.
C'est ton soupirant qui parle.
Ah oui, tu trouves. Quel honneur.
Comme disait une de mes copines, si c'est tout ce que je peux séduire, je tombe 6 juillet.
On avait défini en fait un seuil qui correspondait
which corresponded to at least 5 specific mutation. Well, there is no clear official definition of variants, but clearly what was designated as of December 2020 of variants, you know, the designation of variants, are groups of genomes which have mutation combination very different from what was known initially. The example, of course, is that of the Omicron variant. In the spikes of which we find about 30 mutations, whereas before it was 10, 12. So this is a threshold of mutations which is sufficient to say that it is a new variant. Then after that, the cutoff point, well, you know, it could be in good correlation with the circulation level and with the epidemiological form of such a variant. But then, as I've shown for Marseille 4, we got subvariants as well, their lineage, which have different evolutions, and within the same variant, there could be an evolution leading to a new lineage, which could be considered as a variant. So that was the case for the Marseille 4B. Well, Didier Raoult did observe that, and he mentioned it. He said we should look at the although it is a Marseille 4, it was not a Marseille 4, very different from a new sub-epidemics, if you want. Ça marche, ça coupe, ça marche, ça coupe. Well, what we were able to see in the first periods, which followed the beginning of the pandemics, zones that were limited geographically speaking, at an incidence level which was limited, and therefore possibly there was an increase of incidence at a time where there was a spillover border with a new variant. I can't give you a more precise answer. Clearly, there is this number of mutations per month, which is observed in a recurrent manner, regardless of the context. Yet, having said that, to my knowledge, we didn't look over 1 year in a confined area or limited zone. What was the evolution of genomes, and to see when it stopped, actually. Oh putain, on part dans la 4G, la radioactivité, les antennes, on n'est pas sorti d'affaire. I don't know. Et le fait que ma belle-mère habite chez moi, ça peut jouer? What was shown clearly is that there were passage from human to minks. Some minks were human contaminated, which is the most probable origin. Then, bearing in mind that we know the SARS-CoV-2 now fairly well, there is no other suspected origin. That is, well, there would have to be an independent introduction from of a virus that would be close to SARS-CoV-2. But again, the cause of the presence of SARS-CoV-2 in minks is probably a human source initially. Qu'est-ce qu'il y a? Hein? Ah non, pardon, je pensais que... So let's talk about legal aspects of the associated with COVID. When did you?
Okay, great. So I'm talking about legal considerations about the state of the COVID emergency and why that's no longer the way things are. And let me just start by saying that I'm not an attorney. I'm not giving any formal legal opinions. just some observations that I've seen about how things have happened over the last couple of years. So in the United States, we have a basic idea that in general, and especially in times of an emergency, there's a balance between the normal rights of the individual and what the state, that is the government, needs in order to protect the population as a whole. So maybe the correct word for this isn't balance, but a tension between these two things. In order to understand how this balance or tension is calibrated, we need to go back to the origins of our theory of government. In our 1776 Declaration of Independence, after the first paragraph describing the necessity of the 13 states to separate from England, the second paragraph says, "We hold these truths to be self-evident, that all men are created equal, that they are endowed by their Creator with certain unalienable rights, that among these are life, liberty, and the pursuit of happiness." Now, this is fundamentally a religious idea, that human rights are given by God, not by government, and not in fact because people demand or deserve them, that they're unalienable, they can't be removed, and that they're universal for everybody. People who view these rights in the context of how they were given in 1776 view these rights as sacred. But as we know, grand statements of principle need detailed interpretations when they are put to the test in the real world. So which exact rights did the signers of the Declaration of Independence actually have in mind? The ones that they described are so general that they might include almost anything that a person could do that didn't infringe on the rights of others. So it's been left to the courts, particularly our Supreme Court, to determine the nature of these kinds of rights. And this has also opened the door for the courts to create limits to those rights. And having these kinds of discussions also tends to create a rational approach, though perhaps subjective, for the rights. And today, we live in a very polarized world where a majority of people educated in college or university or further than that have lost an appreciation for the religious sensibilities that were common at the time of our country's founding. Whereas people less technically educated tend to maintain these religious values. Of course, there are numerous counterexample people, but these tendencies still are prevalent and they tend to polarize the discussions. Now, in this polarization, I'm not talking about science questions. Science questions should be settled based on evidence, and so they're rational. The sacredness of fundamental human rights is, however, a values question. If we view these human rights as sacred, then we have to do everything in our power to protect them. On the other hand, public health as an institution has operationalized these rights on the basis of technical considerations. One could look at it as the engineering of health in the population domain. So solutions that work well for most people are thought to be sufficient. And that sufficiency might be even if some rights are infringed, especially for people for whom the public health solutions don't work or in fact are even harmful. And that leads to something like, if you get it right 99% of the time, isn't that good enough? Or 99.9% of the time? If you build a bridge where 99.9% of the cars get safely to the other side, is that good enough? When people assume positions of authority where they're responsible for large numbers of people, dehumanization frequently occurs and the people they are responsible for become abstract entities whose collective good becomes prioritized over the rights of each individual. This comes from a Substack essay by a Midwestern doctor, which I thought was apropos of what we'll see in the Supreme Court in a little bit. So this tension between sacred rights-based values and technocratic engineering solution values mirrors the tension between individual rights versus general public benefit. And that has been a topic for our Supreme Court on numerous different and diverse contexts. For example, this cartoon here, eminent domain, where our Supreme Court has decided that general economic improvements can outweigh an individual's fundamental rights, even if the economic improvements largely benefit one or a small group of investors. Now, in wartime, people understand the degree of threat and readily defer their rights in order to save their country. So fear is what drives this. Fear of a negative outcome of losing the war drives this common behavior. In times of a pandemic, the degree to which people will voluntarily sacrifice their rights is a bit less clear. Fearful people will do so readily, whereas people not so fearful will be more resistant. And therefore, the government has a conflict of interest in spreading fear in order to gain compliance for policies, regardless of the effectiveness of those policies or the cost of those policies. And this is true even when the messages that they spread are completely false. For example, the president and the White House administration put out on December 17th this message saying, for the unvaccinated, you're looking at a winter of severe illness and death for yourselves, your families, and the hospitals you may soon overwhelm. And this never transpired, and there was no reason to think that it would in December when Omicron was spreading and Delta was declining. Now, for 2 years, we've been in a pandemic, not a war. In spite of the fact that in the US, we've got almost 250 years of constitutional legal developments and evolution in legal theory, our legal principles under declared emergencies are still somewhat rudimentary. We declared a national emergency early in the pandemic. Did anybody object? Well, actually, we declare emergencies a lot. Since 1976, when the National Emergencies Act was passed, there have been 58 declared national US emergencies. For the COVID pandemic, we were early on fear-mongered to think that the virus would likely kill everybody that got it. And we saw in the legacy media lots of repetitions of videos of people apparently falling over from the illness in the streets, and we were barraged by constant case counts numbers to make everybody afraid. And based on this widespread perception of threat, we accepted the emergency declaration as part of a seemingly rational plan. The essence of an emergency declaration is that the government has a compelling interest in stepping in to temporarily modify our constitutional protections for our rights. And in part, this is beneficial where it facilitates additional abilities and options for the government to obtain, stockpile, develop, and distribute things like personal protective equipment, treatments, vaccines, emergency clinics, housing, staff, and so on. However, this can also be destructive when the government abuses the emergency declaration to carry out programs mandating involuntary choices that do not have adequate checks and balances. So, for example, inappropriate hospital incentives that have antithetical medical outcomes, vaccinating people that are already immune to the virus, blocking prescription of legal approved medications that doctors want to prescribe, and limitation and censorship of alternative public medical and scientific opinions under the fake premise that such discussions would somehow be dangerous to the success of combating the pandemic. An emergency declaration hinges on a government compelling interest and whether people generally accept the idea of that compelling interest. And part of this acceptance is science, whereas another part of it is values. The scientific part is to evaluate how much risk and damage is likely to occur in the population and whether declaring an emergency will allow extraordinary policies that serve to lower the risks and the damage. Whereas the values part concerns whether people see the limitations on their rights as proportionate to the degree of risk or damage that they face individually or collectively. Now, if a government promotes fear propaganda to overstate the degree of damage, then it lowers the threshold for satisfying both the scientific and the values criteria. And this is effective in people who are susceptible to fear messages, but it's less successful in people who either don't generally believe their governments, like George Carlin here over on the right, who says he never believes anything the government says, or people who have value systems like religious beliefs that make them value their rights to a much greater degree than other people. So did we have a credible, compelling interest in declaring an emergency at the beginning of the pandemic? Well, the WHO and its vested interests, the Gates Foundation and Gates-controlled Gavi, declared the emergency first on March 11th of 2020. We followed suit in the US 2 days later on March 13th. Predictions about millions of dead from the pandemic led people to accept the idea that emergency action would be crucial. And at the time, we had no way to understand the assumptions in the prediction models and whether they were reasonable or not. So it seems appropriate that we did accept at the outset the premise that the pandemic was likely to be damaging enough that emergency action would be warranted. However, we did this at the time without a general understanding of the degree of curtailment of the rights that this declaration would eventually cause. Well, how did this play out? So the pandemic transpired, public health took authority, and made many, many failed policy decisions. Many people died, mostly needlessly. Okay, so now skip ahead 2 years to December of last year and January of this year. In December, the more virulent Delta strain still comprised the majority of infections in the US. This orange bar here was mid-December. And by February 12th, the orange bar that's down here had essentially disappeared completely, to be taken over by Omicron. The two purple and magenta and burgundy colored bars here, and the pink one, BA2 coming here. This is all Omicron. By February 12th, Delta was gone, replaced by Omicron. Omicron is now generating new lineages, but they're all essentially Omicron-like and mild. Well, that Delta was gone in the US was obvious at the time I wrote my Wall Street Journal op-ed saying it was time to end the pandemic at the beginning of February. Now, I wasn't saying that Omicron was gone, but that Omicron was similar enough to the flu, and we don't declare an emergency for the flu. And so we could manage Omicron in our normal medical and public health ways. And the main legal point that I raised at the time was that a declared emergency requires continuous justification. And with the mild Omicron having pushed out all of the previous more virulent strains, the justification was then lacking. As I said, it wasn't that Omicron was gone. We still had, on that date, here's February 9th, 220,000 registered cases. And we're still having 20,000 or 30,000 cases daily, but those numbers continue to decline. But as I've said, the case numbers are actually irrelevant. A pandemic is not managed by its case numbers, but by hospitalizations and mortality. The case numbers are used to scare people. And now we know that the deaths are also going down dramatically in the last few weeks and will continue to do so. So what we're seeing in the US is Omicron running its course to the end, to whatever it's going to do in the end. Whether it goes away completely or stays low level as a very low level endemic, whether it becomes seasonal or not, we don't really know yet. Even if it does, if it were to become seasonal and create bumps or waves, they're likely to be milder than what we've seen before. And if necessary, we know that there are numerous drugs that could be used to treat COVID if they're indicated. I talked about that in my talk to you last year. So how do we know that Omicron has a seriousness similar to influenza? Well, the first way is that there's a large contrast between high case counts and low mortality in the Omicron era compared to Delta before. So what I've done here is I've used the quantitative information from UK Public Health to look at Delta mortality and Delta incidence 3 weeks before the mortality to compute an estimate of the case fatality risks in the pink column here on the right for Delta in last fall versus Omicron in February, March, the same thing here. And we can see that the Omicron CFRs are about a third to a fifth what the Delta ones are. So Omicron is a third or less as fatal as Delta was. Nevertheless, there has been some contentious discussion about the mortality of Omicron versus the flu. Simon Thornley and colleagues published an article in the BMJ and listed a number of issues with this comparison. First, they said that COVID-19 deaths have been overestimated and ascertained poorly. And they base this partly on modeling, but we know now that about half of hospitalizations and deaths in both adults and children have been on patients with COVID, not from COVID. And I've listed here 6 links that you can go to from the PDF version of the talk. You can click on and see the data that show somewhere around half of registered deaths or hospitalizations from COVID are not really from COVID. They're having to people who tested positive for COVID, but not because of the COVID. So we know that that's part of the problem. Secondly, we know that the case fatality risk has been estimated inaccurately because it requires actually validated incidents and validated confirmed mortality. And we don't have those kinds of data. We have what's been put out by public health and governments. And that's the only available data we have to use, so we have to estimate from that. And third, the infection prevalence itself, both for Omicron and especially for flu, is a bit uncertain because the national statistics for that are a little bit iffy. It's hard to find flu data from past years in various countries, and so there's a limit to what we can say about that. A second thing is that patients hospitalized for flu and for COVID have appreciably different comorbidities, so it's a little bit like comparing apples and oranges. Now, interestingly, in January of this year, the Japanese health minister reported, now, so this is not published data, it's in a news article, I think in Bloomberg, you can click that link from the PDF, that the case fatality risk in Japan in January for COVID was 0.13% versus a typical seasonal flu of 0.06 to 0.09%. So that made it look like COVID is a little more fatal than flu. However, Japan is a much older population than the UK and other Western countries. And that can be seen here, where here's the age structure of the UK in percents of the population by age group, Japan by age group, and you can see that Japan has a lot less people in the young age groups under age 40 than the UK, and has many more people, especially over age 70, than the UK. And what we also know is that according to age, COVID mortality is much higher, much steeper with age than flu. And this is almost threefold, the slope of this is almost threefold compared to flu. And so when you take these age differences and you adjust the 0.13% and the 0.06% down to a Western population percentage, that COVID adjusts more steeply than flu, and COVID and flu become much closer together. And this clearly suggests that Omicron has no greater mortality than flu, and maybe even less. So given the comparability of the Omicron versus flu, what's the current justification for maintaining the pandemic emergency status? In other words, what's the government's compelling interest at this point? Well, case counts are not a compelling interest. No other respiratory infection with as large or larger case counts has ever created a declared US emergency, at least in modern times. So forget about SARS-CoV-1 and MERS, they were much smaller and they fizzled. So not polio, not Asian flu, not swine flu. They were not declared emergencies. Hospitalizations, as important as they are also not a compelling interest for the government. If more hospital beds and facilities would have been needed, then some of the billions of dollars that were spent unnecessarily on vaccinating people who were already immune because they had already had COVID could have been used. So poor planning is not a justification for curtailing human rights. Third, a hypothetical risk of a severe future COVID pandemic is not a compelling interest to maintain an emergency. There's no reason to think that a future wave will not be derived from an Omicron lineage and thus be comparable in severity to Omicron and its current strains, for example, BA2, which is not more severe and maybe even less severe than current Omicron, regular Omicron. And more importantly, fear of a theoretical event is not a compelling interest. In the unlikely event that a new severe strain were to emerge, then you could declare an emergency again. Now, we know that a compelling interest for a pandemic must be based on mortality and the tools needed and available to control the mortality. And in reality, we have had the tools to control COVID mortality all along. So what I'm showing you here are meta-analyses of, on the top, hydroxychloroquine, the bottom, ivermectin. The right column is mortality. Both of these drugs reduce mortality risk by 75%. And this is true, we know it's true, in spite of the information war launched against these meds by pharma, NIH, FDA, WHO, Fauci, etc. And we know this because in addition to these data, we know that more than 150,000 Americans, in fact, more than 200,000 Americans, have been treated largely by telemedicine groups over the last 2 years with these medications, and in total have shown essentially 4 or 5 or so deaths out of this entire large group of treated people. Now, a legal precedent for government compelling interest in the pandemic was actually given in the 1902 smallpox epidemic, Our Supreme Court in the case Jacobson versus Massachusetts in 1905 ruled that the state of Massachusetts could compel residents to obtain a free vaccination or a revaccination if they'd already had it against the infection or pay a $5 penalty, which is about $150 today, for not getting the vaccine. Now, I'd say parenthetically that at that time, the mortality from smallpox was 20 to 30% of cases, and the penalty then wasn't losing your job. So I'll get to Jacobson case in a moment. On October of last year, our Supreme Court declined to take up the case of a vaccine mandate challenge in the state of Maine. Arguing for the majority of the judges, Justices Gorsuch, Thomas, and Alito maintained that although 11 months earlier, the court said stemming the spread of COVID-19 qualified as a compelling interest, this interest cannot qualify as such forever. So why not? Precisely because these justices wrote, there are now 3 widely distributed vaccines. 11 months earlier, there were none. And at that time, the country had comparably few treatments for those suffering with the disease. Today, we have additional treatments and more appear near. And this makes it clear that what constitutes a government compelling interest depends on the context of what's happening at the time. Now, in the Jacobson case in 1905, Justice John Marshall Harlan, the Chief Justice, presented 4 criteria that needed to be shown for the vaccine mandate to override individual medical freedom. First, that individual liberty does not allow people to act regardless of harms that they could cause to others. Secondly, that the vaccine mandate was not shown to be arbitrary or oppressive or capricious, say, that vaccination was required for public safety, and the defendant's view that the smallpox vaccine was not safe or effective was not a real opinion. It was a minority medical opinion. And this is an example of what today we regard as legal scrutiny criteria, the standards that need to be satisfied in order for the government's interest to prevail against individual freedoms. Scrutiny standards range from the weakest, what's called the rational basis test, to the strongest, what's called strict scrutiny. And the strength of these criteria, there's 4 or 5 levels of these scrutiny criteria, the strength of it should be proportional to the importance or degree of the rights that are to be overridden by the government interest. And these Jacobson criteria that I've shown here are today very close to what's required for what we call strict scrutiny, the most strongest form of scrutiny. Now, Jacobson argued that individual liberty does not allow people to act regardless of harms they could cause to others, and vaccination was needed for public safety. And so this implies that the compelling interest was in preventing spread and mortality. So the question is, how much mortality is the compelling interest? In daily life, in our society, we take mortality from numerous causes as just part of how society is, how life is. So in the US, we have about 30 to 40,000 traffic accidents per year. We don't declare an emergency over that. Normally, in typical flu seasons and other respiratory viruses, RSV, for example, we have 45 to 60,000 deaths per year. We don't declare an emergency for that. We have non-traffic, non-car accidents. Every year, 160 to 170,000 accidents per year. We don't declare an emergency for that. And we have smoking-related deaths of 500,000 per year. We don't declare an emergency for that, and our government has never done anything significant to try to change that. So if we had 1 million COVID deaths over 2 years, half of them with COVID, not from COVID, why is that an emergency when the smoking-related deaths, which is double what we've seen from COVID, is not an emergency? And now with Omicron, with a mortality of 1/3 or less of those 1 million deaths, with cases and deaths declining rapidly, with strong herd immunity, why is it still an emergency? So prevention of COVID now is perhaps a desirable policy goal, but it's not a compelling interest. And in fact, Justices Gorsuch, Thomas, and Alito wrote, at some great height, after all, almost any state action might be said to touch on public health and safety. And measuring a highly particularized and individual interest in the exercise of a civil right directly against these rarefied values inevitably makes the individual interest appear less significant. In other words, state interest always seems grander than individual interests or rights. So the justices also wrote If human nature and history teach us anything, it is that civil liberties face grave risks when governments proclaim indefinite states of emergency. And this is what we have today, an indefinite state of emergency and the government abusing the emergency declaration to maintain it. And I argue that it's well past time for people to start using legal actions, legal methods to end this abuse of the emergency. The pandemic cases need not be over for the emergency to be over. The emergency is indeed over based on all of the principles that we know, both for the government's interest and compelling interest, and for what the pandemic is doing. So I'll leave you with this humorous image there of Fauci and his performance over the last 2 years, which would be funny if it weren't so sad. Happy to address any questions.
So, Dr. Rich, do you hear me?
Yes.
Okay, I will take the questions from the room, from the attendants, and repeat them to you or translate it if they are in French. Okay. Est-ce qu'il y a des questions? Vous pouvez les dire en français ou en anglais et je les transmets par là. Oui?
Est-ce qu'il y a déjà des actions qui vont être entreprises, des actions légales, comme a parlé M. Kirch? Est-ce qu'il y a des actions légales qui sont entreprises ou qui vont être entreprises?
Can you please tell us about legal actions done like to protect the people against government abuse?
Well, it's very difficult to have actions. We have many lawsuits against employers, against states, now against the vaccine mandates, some lawsuits against mask mandates. We are also likely to see increasing numbers of lawsuits, especially coming from the insurance industry. That the insurance industry has been seeing, both in the United States and in Europe, have started seeing a very large excess of non-COVID related deaths in the second half of last year compared to the second half of the previous year, 2020. And it's very clear that these non-COVID related deaths can't be blamed on COVID and COVID related issues, and therefore can only be viewed, because it's a 40 or 50% excess of deaths, cannot be a random statistical signal, has to be coming from something that happened that's not COVID related, and therefore it's viewed as this is coming from inconsidered deaths from the major vaccination programs. And so the insurance companies are gearing up to sue the vaccine manufacturers for hiding the all-cause mortality or non-COVID mortality in their original trials. And in fact, we know that Pfizer did have data on all-cause mortality that it did not make public at the time of its trials. It's not a large amount of data. One could say, well, these were not statistically different. Nevertheless, that should have been made public. And so the insurance companies are gearing up to do that job for us. We as individuals have a hard time fighting back when there's corruption of the major legacy media, and we only have alternative media to get messages out, and we're being smeared completely that we're anti-vaxxers, which is not true, that we believe in unproved theories, unproved medications. We believe in that the pharma industry has rolled out half a dozen fake hydroxychloroquine randomized trials in the same way, using the same playbook that the tobacco industry made fake studies of smoking in the 1970s, showing that smoking was safe. And you take a large amount of money, you corrupt people to do these studies, and you put out corrupt studies to try to counterbalance the real studies that I showed you. This is all part of the game plan of misinformation that we have to counter, and we only are able to counter this through our alternative media, but the messages are getting out, and people who are not afraid, who don't have fear as what drives their decision making, are more receptive to these messages, and this is becoming more and more publicly acknowledged.
So these days in the States, hope comes from the insurance industry, right?
Yes.
Okay. I checked. Oui?
Est-ce qu'il n'y a pas des problèmes de lien d'intérêt
Oui. Do you think that the insurance industry is like interest-free in this issue? Do you think they have just a honest interest in human rights, or do you think they have they are also fighting for their money?
I think it's both. I think the pharma industry is completely taken over by money, by the interests of its stockholders and CEOs. The insurance industry is a little bit different because some of the insurance companies arose from religious groups that wanted to do something that have a moral component to their corporate behavior. And this doesn't mean that they ignore their financial health. And in fact, they are very careful about that because they're regulated and they're evaluated by auditors who give them ratings, A+, AAA, and those financial ratings that tell investors whether it's safe or good to invest in those companies. So they are also careful about their profitability. And their problem is when people are dying too soon, if this were about 80-year-olds dying a few months early, then the insurance companies wouldn't really be bothered much. But when it's about 60-year-olds and 50-year-olds dying, those people get their payouts from their insurance, but they don't pay their premiums for 20, 30, or 40 years. So the insurance companies are going to be losing a lot of money because of those excess deaths in working age people. And so they're very concerned about that financial loss, and that's what they're using to go after the pharma companies.
Okay, thanks. Oui? Well, about these, is there any lawsuit already started from the insurance industry, or is it just something brewing up?
The lawsuits have not started yet. The insurance industries companies are facing their auditors and discussing with them what's going on and how to deal with it, that they're not prepared to lose all this money. They're not prepared to raise their rates 40%, their premium rates 40%. So they are in the middle of working on this, and this is evolving in real time now in the next few weeks. We'll see what happens.
Okay.
C'est légèrement différent, mais j'entendais sur France Info il y a 2 jours, donc quelqu'un qui disait que maintenant un traitement existait, donc je suppose que c'est officiel cette fois-ci, qui évitait les cas graves. Donc je me demande pourquoi est-ce que l'autorisation provisoire, enfin l'autorisation de l'AMM provisoire pour les vaccins s'est pas arrêtée, puisque la condition était qu'il n'y ait pas de traitement, surtout qu'on va même les autoriser pour les enfants maintenant. Comment est-ce que l'existence de ce traitement n'a pas court-circuité en fait l'autorisation provisoire de ces vaccins qui sont encore en phase 3 d'essai?
Okay. Question from in the room. Since there is at least one accepted treatment for COVID, why hasn't that stopped, like let's say the authorization of untested vaccines, or let's say not so tested vaccine, to be put on the market? So I think the person was referring to the Pfizer treatment, right?
Yes. I was saying that I heard the condition, the reason why this vaccine had this authorization, it's because of the lack of treatment. But I heard that now there is treatment. I mean, like official treatment. So why this treatment, the fact that this treatment exists, did not stop this temporary authorization?
So my understanding of this is that the FDA that does these authorizations is basically a theater, not a real. They use science as the pretext for what they are. Is really, it's been said they're the public relations department of the pharma companies. And so what they do is a pretense. And that means that their requirement of having no actual treatments in order to approve emergency use authorizations for vaccines is supposed to be a criteria, but you might ask, why are there 3 vaccines? Why wasn't the first one sufficient to block the second and third? And the answer to this in part is that all these things have to be generally available. The early treatments that have been approved, the Paxlovid and molnupiravir, are not easily available. Furthermore, the Paxlovid has got a lot of interactions with other medications that people can take, and so it's not clear that everybody can take it, and it's not generally available. So the FDA can't just say you can't get vaccinated because we've got a treatment because in fact it's not so available. But in fact, the FDA never really held itself strictly to the criteria of there being no other treatments. It did in terms of blocking hydroxychloroquine, because it wasn't just that if hydroxychloroquine was available, then it couldn't approve the vaccines. It's worse than that, because it knew that if you could give a treatment that costs $4 to treat COVID, that no vaccine would ever compete with that, and no medication would ever, a patent medication would ever compete with that economically on a fair economic playing field. So they knew they had to block it based on economic reasons, not just on whether they had a reason on one of their slides at one of their meetings saying that they had to do that.
Est-ce qu'on a encore des questions? On termine? Okay, Dr. Rich, thanks a lot. We move on to local speakers. Thanks a lot for taking.
Okay, thank you. Great to be with you all.
Thank you. Thanks a lot. I will get
Okay.
day with you. Thanks a lot.
Thank you. Great to be with you.
Bye.
Bye.
Et maintenant, je vais appeler Laurent Toubiana qui va nous dire comment mesurer et évaluer l'épidémie de Covid.
I work at the INSERM. I work in a unit called Medical Information and Medical Knowledge Engineering. That's the name of my unit. People say I'm an epidemiologist, but I usually work within an IT team, so that's why I wanted to stress that I work within an IT team. I've been working with them for a long time and I worked hard to create this team, but other researchers told me it was better not to mention this unit. So as you can see, I'm not mentioning it at all. Actually, I work with a group called Epidemiological and Complex System. I created the IRSAN. You may have read some analysis from this group. The IRSAN runs analysis and I write them down. So I changed the title. The title of my presentation will be describing and assessing COVID. So we've been... And I will dedicate this presentation to geniuses who have diffused, we have spread this slogan: we can debate, we can discuss everything except figures. And this slogan is a good representation of the situation and the mindset with whom we can face this crisis. Thank you, sir. There are many ways in which we can describe an epidemic, and each participant here has described one aspect, one dimension of the epidemic. But for doctors, an epidemic are sick people, people who die, doctors cure them. But if you're an epidemiologist, when there's an epidemic, there's sick patients and a patient who die, but it is quite abstract. It is actually constructed. So epidemics are important, are significant when quickly the number of sick people is really high. An epidemic is said to be serious when very quickly the number of deaths is higher than expected. And we will show with this presentation that for epidemiologists, COVID epidemic isn't significant nor severe. So let's imagine that we talk to serious people. We're talking to serious people, so we expect the serious people to use serious methods. Methods that have been acknowledged in their field of specification. So here are serious people describing the epidemics. Well, we may not listen to these serious people in the end. Sorry, it was just a joke. $82,000 in China, 120 people have been cured, 75 countries have been touched by the epidemics, and there is the epicenter of the pandemic with over 200,000 cases. So that was just a joke. It brings back awful memories, actually, and yeah, we didn't want to listen to these people because in the end they were not that serious. So this person is supposed to be competent at describing epidemic with absolute numbers, cumulative numbers every day is heretic. So we're talking about a transmissible infectious disease epidemic. This is a phenomenon based on space and time. And to describe this kind of epidemic that was quite quick to spread, people considered serious in the field used what we call the incidence or the incidence rate. So how can we measure incidence? It's quite simple, actually. Here are 4 pages of calculations, but you can sum it up with this equation. But really, to sum it up, you only need this. That is the number of new cases within a given population in a given period of time. So this phenomenon is space and time based, but what the speaker said is different. There was a cumulative number. We don't know much about it. We can't understand it. And this cumulative number goes up day by day. These figures are given every day. These figures go up. They make time longer because usually incidence is communicated once a week. So for any epidemics like the flu epidemic, the common epidemics we know, so there are about 12 to 16 announcements during any given epidemic. But for the COVID epidemic, there were about 70 announcements. So time is slower, tapas is slower. So we're not talking about epidemiology anymore, right? So you've all seen this kind of a graph. This is a graph that shows the incidence rate these past 27 years. This data has been collected by the Sentinel network, and it shows the number of new cases of flu in 1 week for 100,000 inhabitants. So there are 1,924 years, which are weeks actually on this chart. So we provide a lot of figures to the population, and when you do, you need to explain what they refer to, and that's what I'm going to explain to you. During the last epidemic season, and after that there was COVID and then nothing. So the last season of the flu, during this last season, the flu wasn't really strong, and I'm going to show you the highest incidence rate of the epidemic, meaning the incidence peak. This is a crucial moment because it gives us hope. It means that the curve will go down. So that's what we call the Gaussian curve, a bell-shaped curve. There is a climax, a steep increase, and then a steep decrease. That's why we have hope. So the peak represented 314 cases for 100,000 inhabitants. So it's quite difficult to imagine what it represents. So to give you an idea, let's take Aix-en-Provence, which has 150,000 inhabitants. So can you imagine that during 1 week there were 314 cases of the flu for 100,000 inhabitants? Let's take another season. In 2015, there were 800 cases maximum for 100,000 inhabitants. So why did I choose 2015? Well, maybe you remember there was a scandal. Emergency rooms were saturated, and Mrs. Sorel announced 5 million deaths, and it was the middle of epidemic, and almost everybody was vaccinated, although we were late. So it was a scandal. Then I was heavily criticized because I had anticipated the occurrence of the epidemic, and I didn't predict 5 million cases, and I paid a heavy price for this then. Now let's take 1988, 1989. This is the highest peak that reached 1,793 cases for 100,000 inhabitants. So end of story. So how does it all work? It's quite simple. There's a censor in France represented by general practitioners, and while they work, GPs will observe the number of cases of specific conditions. So this is a representative sample of observational doctors, and we report the number of cases they observe. So we collect information, we collect data. It is a fragmented collection all around the territory, but our aim is to disseminate knowledge, a piece of knowledge because nobody can know what happens in practice. So Laurent asked me to provide you with a description of the epidemic, but there's something else we do. We also raise alarm, so we warn people against the occurrence of an epidemic. So we must anticipate the occurrence of epidemics so we can warn people in advance and set up preventive measures. So we do that before the occurrence of the epidemic, not in the middle of the epidemic. So we need some early detection models for epidemics. Thirdly, we also use predictions. So we need new models, other models, so we can predict what's going to happen. So I think that there will be a speaker, there was someone will speak about mathematical models after me. However, I would like to comment on what Pierre Sonego said this morning. I really liked his presentation, and I think we agree. It is quite surprising because we don't work in the same field, but this shows that people can have different culture, different trainings, but they can reach the same conclusion. They can obtain the same results. I'm quite surprised in the end that there are not many more of us with the same conclusion. So this morning I was really surprised because he mentioned the prey-predator model, and so I made some research when I heard this term, and it's about 30 years ago. I suggested an original model, people-centered model to predict epidemic dynamic, and it is a prey-predator based model. So people, the human being is an elementary space, and it will host the interaction between a pathogenic load and the immunity. So the contact between people can transmit pathogenic agent and can lead to the emergence of epidemics within a population. In the end, it is a lesson for everyone, for all the people that thought there would be about 500,000 deaths at the beginning of the epidemic. That's what they said, and it makes me smile because it's not serious. It's not a serious thing to do, and nobody can talk about such explanation. Nobody can let such model be used to carry a prevention campaign. So here's a model. So this is a video presentation. There are viruses, there are antibodies, there are two different differential equations. They're really simple, but I won't go into detail. So as for the diffusion of viruses, there are these two equations. You will add this system. This is a diffusion component. I will not go further. I didn't mean to show you these slides, but I thought it would be interesting. So this is a model of the epidemic, of the spread of, this is a model of an epidemic, and I also applied the same model to the whole French territory. This dates back to 2016. It's quite, no, it dates back to 96. So we made a simulation of the spread of the virus with this model. I would have never thought of setting up a lockdown with this.
So back to the chronology of events of as of in the 1st September 2020, January 22, first information from China. February 8th, the peak is already reached in China, and February 22nd, first cases come to Italy. At the same time, in the meantime, the networks already identifies things, detects things, and notably another network, I talk about the Sentinel network, but this is another network of doctors. It's SOS Médecins, you know, the emergency doctors in France, where we had I worked with them because we had designed together a monitoring network based on their data. Nobody talked about that yet. It was important because we're dealing with patients, you know, sick patients. On March 7, first official cases are noted in France, and the IRSAN publishes an analysis of the situation, survey of the situation, and what's going to happen, basically. And don't panic, basically. Don't, you know, keep cool. Then, March 11, the president's speech, where he announces the first confinement or lockdown, and I was amazed because, you know, to me there was, you know, everybody was amazed. I mean, even himself, I'm sure, was amazed because the first data from the Sentinel network came 1 week later, I think, and at the end of the day, well, the week of 23rd, 26 March 2020, in number of sick patients, we reached the peak I mentioned early on. It so happens that the peak, I did plan it, I did forecast it, and I gave in my analysis exactly the date at which it would happen. And I didn't know there would be confinement. That this confinement was not necessarily good, but it might be a hasty conclusion. So what you see are the two curves. The red and green is the Sentinel network. The blue one is the SOS Médecins network. That is first-line doctors. Okay. Again, this is another aspect of the lack of seriousness of people who give us trouble. A case is not a patient. And I mentioned, is it semantic manipulation or manipulation and end of story? As of summer 2020, we're dealing with the major innovation with what I call the testomania. For the first time, we use tests to, c'est pas les testostérone. So it wasn't to confirm a diagnostic, but to test the population, general population. Everybody could go and get tested nicely. I don't know, I thought it was quite odd anyway, but since then, 230 million tests have been carried out. So we are 67 million in France, children included, at least 3 tests per individuals. Why? Back to a phrase from Sanigo early on. You find what you're looking for. Well, this is what we are looking for. And at the beginning, there was no test. So we had 120 cases confirmed for 100,000 inhabitants, which was reasonable. Then afterwards, now we move on. This is October. We get to the peak up to 503 cases per week for 100,000 inhabitants. 503 cases per 100,000 inhabitants. You can see the. Then it drops, and then we get to the 5th wave, where I started acting on the radio. I started talking on radio because the wave story was getting on my nerves. So, okay, I said, okay, you know, how many times are we going to run this? And I looked at the number of cases. This is when we went from testomania to insanity. And this is quite visible, you know. Insanity is this. That is basically, we went from 3,776 cases per 100,000 inhabitants. What we saw as a second period, the so-called wave or second episode, was 503 cases. So now, if we are to look at the true patients, or the true sick people, the true patients. So back to something visible, that is, I removed the fifth wave. You know, the fifth wave is quite insane. And let's look at something where it is visible. 503 cases for 100,000 inhabitants. How many patients? 83 patients for 100,000 inhabitants. This is what you get when you go wild on the fifth wave. 3,776 cases. How many patients? Sick people? 126. 126 patients. That is, at the beginning, it was 6 times more. Now it's 30 times more of cases than patients. So, positive cases to a test are not sick patients. At the maximum during the second wave, there were 83 patients sick for 100,000 inhabitants per week, which is about 6 times higher in terms of cases than sick patients. Second wave, 30 times. So if given authority want to convince you that the epidemic is dangerous, well, it's better to talk about cases than to talk about sick patients. Even more so that for most cases, a case is a patient. You know, okay, there we go. Now, back to the little history of a small epidemics. I've shown you the curve. It is the first through, in my opinion, through epidemics. There were patients who were sick and who died, but 140 for Sentinel, and for the SOS Médecins Network, there were 138. So very coherent. We're happy. And then for the rest of the time, still very happy. You see first wave, second wave, third wave, fourth wave. You know, I hate the word waves, but, you know, I'm using it because everybody understands it. And you see, waves are smaller and smaller, except this one. But what's surprising, though, is that we got 126 patients on the Sentinel side, whereas for SOS Médecins, it's only 77 patients sick. That was very coherent until then, and then all of a sudden there is a discrepancy. It is less coherent. So I don't know if it is due to my amazing notoriety, but at a time when I started finding that the number of positive cases was quite high versus what was going on, I was saying, but look, we don't have that many sick patients, only 32. All of a sudden, it's amazing, but there were more sick patients on the Sentinel side. It so happened that Sentinel is controlled by Santé Publique France. We'll come back to Santé Publique France later on. So comparison is not a reason. So back to this, but another scale. Let's look, you know, at a seasonal period over 1 year, and I focus, you know, I center when something happens in winter period, so as to really see the phenomenon. This is when the COVID epidemic strikes, March to May. What's more, 143 patients. You know, remember, it was much higher for the flu. 138 for SOS Médecins, 36.5 hospitalized, 6.7 patients in critical care, and 5.2. Comment tu fais 5,2 morts? 5,2 morts. That was the first major epidemic. The others were much weaker. So 37, 32 for August. In August, by the way, it's I fear that this is a false epidemic in summer. In my opinion, it corresponds to Macron's speech. So Macron generates epidemics because immediately after that there was a vaccination wave. This is the famous fifth wave, but we could see that it was somewhat tricked. Now, you can see here the last one, flu epidemic, 224 patients for 100,000 inhabitants. This is the COVID, the first one, 140 patients. It is exactly in the same conditions, that is, same network. There was the fact that doctors didn't have the right to work normally. This had an effect on the collection. But anyway, those are incidences. The fact that there are less doctors increases the confidence interval, but incidence is good. Now, this is the previous flu. You see, it goes very high, but it's very broad as well. A lot of people there, you know, the area under the curve. So, and now I'm showing you the very famous 2014-2015 epidemics, which was the highest in terms of peaks, but not the most severe one in terms of number of patients. The area under the curve is equivalent, slightly more than usual, but not that much more. And this is the famous January 2022 epidemics, you know, 626. It's very reasonable versus what we call, you know, trivial or banal epidemics. So the 2014-15, 2.8 million patients sick, and the COVID first episode, 0.2 million patients sick. So all this information was put online permanently on the IRSAN website, and they're still available, and it is being enriched. So Santé Publique France is an agency for the implementation of healthcare policy in France. It creates a bias and gives a dramatic dimension to the information in time of crisis. We saw it for COVID, but it was already the case for the flu. They did the same thing systematically. I'll spare you the details, but I did present that elsewhere. So the choice of the healthcare authority in the management of the COVID epidemics and the implementation of disproportionate measures in all respects, thus they sacrifice most of the population without any distinction instead of protecting vulnerable individuals. Vis-à-vis seasonal epidemics, the COVID epidemics is a minor epidemic. It could have been almost ignored if the healthcare system, GPs and hospitals had been normally used. The crisis COVID was not generated by the epidemics, but by the catastrophic management thereof. Thank you very much. Ah oui, ça de toute façon, il y a beaucoup de mecs qui disent que c'était une crise du système hospitalier, c'était pas une crise. I'm sorry, I'm not getting the sound from the room, so I cannot translate the question. Together with Laurent, he reminded us early on, we tried to assess this mortality. There were casualties indeed. We did a study. If there is a bias associated with the link to the qualification of the death, not only people who died were older, they had other comorbidities, so lethal comorbidities. We made a choice to look at the death with all causes included, and it's called the over mortality calculation when there is an event. So we did the calculations. We were very, very stringent in this calculation, and we considered that in France there's been a very low over mortality through two epidemics, spring and fall. Very weak mortality for the population as a whole. very low mortality for the people over 65 and no mortality or even under mortality for people under 65. I agree with you. Yes, whatever the question was. Thank you for your question. Sorry, I didn't get that. I read an article recently and asked myself the question. In fact, we're not dealing with. It is an assessment, an estimation. So that is, it is a survey. You know, in a survey, I can have plus, minus. I mean, you know, there is a varying representativity. Even if activity was reduced, it was not entirely eliminated. And I did it on purpose to show you that the network of first-line doctors, that is when there is an acute problem, that is SOS Médecins, well, they already had started working on this. And I looked at their activities. It dropped during the crisis, during the first epidemics, but yet the meaningfulness of their figures is still valid. Putain, qu'est-ce que je traduis, hein, des fois. Dis-je en toute modestie.
Tu te balades.
So pleased with myself.
Moi, j'étais pas pleased with myself ce matin.
Hein?
Moi, j'étais pas pleased with myself ce matin.
C'est-à-dire, une fois, comme j'avais dit une réunion d'interprète à Paris, je dis.
En fait, c'est d'abord les puces et les rats en fait associés.
Oui, il y a un vecteur supplémentaire.
Il y a un vecteur supplémentaire. Et en fait, on peut se dire très naturellement que si effectivement les puces infectent les rats et les tuent tous, bah, elles vont eux-mêmes diminuer parce qu'elles n'ont plus rien à manger. Et du coup, si les rats augmentent, bah, les puces aussi vont avoir plus à manger. Donc on est clairement dans un modèle propre-prédateur. Et il y a une caractérisation qui est que les courbes de peste à Bombay donc, sont périodiques et elles sont symétriques. En fait. Donc c'est deux caractéristiques mathématiques qui font qu'on pense beaucoup plus à un modèle propre-prédateur eu égard à la manière avec laquelle ça se transmet qu'un modèle de type PCR qui était inventé. Alors ma question, puisque tu as utilisé le modèle propre-prédateur, c'est dans quelle mesure ce modèle avait déjà été utilisé avant toi en épidémiologie, parce que ce n'est pas forcément un mode naturel effectivement de transmission des maladies, mais quelque chose qui passe par un vecteur extérieur. Et dans quelle mesure ça dit des choses, par exemple, sur la manière de se transmettre le virus?
Alors, ce modèle a très peu été utilisé, en effet.
Seldom used, very seldom used. It has a, well, you mentioned it, yeah, it is auto-organized in time and space. And therefore, this spatial-temporal auto-organization is interesting when we want to show recurrent aspects. So that's why I used it at the time. What was interesting for me was to know if a system may have its own dynamics as this one and can be set or tuned to other dynamics, such as the fact that seasons, because based on seasonality, you know, this was the synchronization that was interesting. That's why I tried to work on this point. But again, the question of modelization was funny for a while, you know, was entertaining for a while. I don't want to outsmart everybody here, but for me, those are explanatory models which makes it possible to understand the phenomenon, but they are not operational models. And this is a problem. We try to understand how it takes place. It's very well to give it to the students so that they will understand, so that they can see. Early on, Pierre gave us a brilliant demonstration. He didn't need a model to talk, and he talked without papers. We understood. And this is what it's like, to try to understand the physics, the mechanistic model, but now to do public health with that, it's a bit bizarre, but it's odd. This is what tickled me. Gotta stop, we're late. Sorry. Oh, we'll close too late otherwise, sorry about that. On est combien?
C'est lui, il y en a encore deux, normalement.
during the first year of the COVID, and what is the clinical profile, because what are we going to say is known, but just able to set the context. And we did published an article on the number of deaths, because we had a number of life years lost. And then we did a second body of work, which I'll describe today, on patients died during the first year of the COVID in Marseille and Nice University Hospital, because in Nice, do they have the same results? I mean, do we see similar trends or other? Because at the time we didn't have all the information we have today. And today, in fact, I continue to work with the IHU for epidemiological monitoring or surveillance, and we look at the number of patients who die, and we look at patients under 65 to see how it evolves according to variants and so on and so forth. So second work is submitted to a journal. So these are the number of deaths. It was a topic, so because a lot of patients died of COVID, and it is something that raises questions when you're in public health care, and especially on these epidemics. The objective of the work was clearly to define the sociodemographic and clinical profile, exhaustive of all patients who died. We didn't modelize anything. We went back to clinical data and to the patients' dossiers. And we wanted to identify the profiles of the patient who died prematurely, that is before the age of 65. And we wanted to compare. We compared the various epidemic period, and we continued, and we will see that we're still dealing with the same types of patients. So what did we do, concretely speaking? We did a retrospective analysis of all the patients who died in the two university hospitals in the PACA region. The patients had been identified by the information and clinical data system of the hospital. And then we went back to clinical data of the patient to organize an anonymous basis, where we got, in addition to the gender and age, were they at home or in institution, level of autonomy, comorbidity, and the intra-hospital residence, the mode of admission or entry, did they go to resuscitation, and and so on and so forth. And finally, we collected the date of the positive PCR to position them in the various periods. And of course, even though we didn't have at the time we didn't have the individually, we had not collected the variants concerned, which is something we do now. Now back to from Philippe Cosson's the period. You see, this is the first wave, and mainly the Marseille 4. We were at the beginning of the wave, which was on the English variant. So 92 casualties. So we recovered the cause. Did the person died of the COVID or with the COVID? Died from COVID or with COVID? I mean, could it be assigned directly to death? Could be assigned to the pathology, or it is because with time there are more and more PCR tests which are done for other reasons than just entry into hospitals, and we can see that in 2021 we had slightly more deaths which were not caused by COVID, but about you see the percentage of deaths, people who had positive PCR but who did not die of COVID. So it shows you the death rate. So we can say per month, we can see that we've got the death rate which are roughly initially less than 10% in Nice, where there was a higher rate, and then the number of deaths per patient in hospital is roughly 15% roughly from the start, and today we're still monitoring that. It's roughly 10%. Again, it depends on the periods. And then in absolute numbers, it shows you the number of patients in hospital, and we classified the number of patients who died. So now we are looking at the mean age of the patients, something known. 80% plus of patients were over 70, and though the older the patient, the higher the number of deaths. in this age segment. Mean age 80 years plus minus 11, minimum 22, max 103. And the mean age remains roughly stable in the epidemiological survey. It went down to 77, and mainly they were men in 62% of cases, and 105 patients, roughly 10%, who died before the age of 65 in this period of the first year. And today we still have patients under 65 who are part of the casualties. Indirect indicators of quality of life level. Well, you can see in blue chart is the loss of autonomy. In the orange curve is the fact that you are in bed, you can't move. And in gray, the fact that you are institutionalized. Among deceased patients, half of them have lost their autonomy, and it's much higher. We'll see it on another slide. In the first wave, there were a lot of deaths in the pensionist home. 95%, 52%, 14% of the patients were actually unable to move, and 21% were institutionalized. So in the first wave, there were more patients in that situation. Now, those are comorbidities. Well, patients had at least 4 comorbidity plus minus 1, 2 plus minus 2, 1. 6 patients, in all the patients who died, 6 patients had no comorbidity whatsoever. Well, I mean, it's not to minimize this, but those patients were patients who had been transferred. Maybe they had comorbidity which had not been diagnosed, but we didn't find anything. And out of the 6 patients, 5 were under 65 and 1 was over 65. So most of the comorbidities are conventional. A lot of people had hypertension, cardiac disorders, neurological conditions. Well, all neurological diseases, Parkinson and so on and so forth. Diabetes, of course, 30%, which is quite coherent with the figures. And then respiratory disorders, vascular disorders, cancers, of course, psychiatric conditions, and overweight, obesity, 14.2%, as well as autoimmune and genetic diseases as well. Now, the health care process, well, 75% of the patients came through the emergency services. The figure remained constant from the start, whereas the pathology was better known and the management modalities had been improved, but we could have expected less entries to urgencies. 5.6 had been admitted directly into resuscitation of emergency care, and 26 had been transferred into resuscitation, and 2/3 of them in the first 24 hours. We looked at the first 24 hours because those patients came in a critical condition and they were rapidly transferred to resuscitation or intensive care unit. The characteristic of patients depending on the epidemic period, age segment, where you can see that the number of patients who died is not the same depending on the period. We had 226 in first wave, and then 481 and 374, although it was not the end in period 2 and 3, but mean age is roughly the same. There was slightly younger in the second period, but not statistically significant. But where there is a difference, you see, patients who died who came from institutions were a higher number in the first period, which is associated with the crisis of the old pensioners' home. After that, they corrected the situation. Then we have the emergency entries and more transfer in ICUs, intensive care unit, in period 2. Now, we also look at the features or specificities of those so-called younger patients under 65. Only 21 had less than 2 comorbidities, men, 2 patients who were under 40, and all those patients had been admitted in intensive care except 2 who were in terminal phase and who had another severe situation other than COVID. And among the patients who were admitted in intensive care, half of them had been admitted very early in the 24 first hours. Now, we did regression models, multivariate analysis regression models, to see what were the specificities of the patients under 65. Well, basically, we did a model where we take several values of body mass index, for example, to see the weight, the role of obesity. And if you take if we paid attention to the by doing strata with the BMI, we had 6 times. There was a higher number who suffered from a genetic disease, where it was more present in younger patients, and they also had metastatic cancers, a higher number, people who often had cancer and severe diseases, and they were in ICUs. But since the intensive care unit is associated with, all this was quite coherent. And when we look at the stratas under 40, there was 3 times a higher number in terms of massive obesity. We did a main component analysis that makes it possible to project data and to see in an exploratory manner how data or sort of are hinged, or how they sort of overlap if we don't have clear hypothesis. Well, 3 types of patients, 3 cluster of patients. Our first group, more the first wave, patients who are very old, loss of autonomy, and who were more institutionalized. They came through the emergency unit. Actually, they died in the ICUs, most of them, and who had quite neuropsychiatric comorbidities, strokes, hemiplegia, cardiac problems. In the middle, it's 2021 patients who were losing their autonomy but who were still at home, what we call we call them the fragile patients who are old but who are still at home, who are somewhat losing their autonomy but are still like independent. They're home, and they came through the ICUs, and they died during the hospital stay, and they had comorbidities, hyper blood pressure, kidney cancer, cardiac diabetes, thyroidal problems. And then the group of younger patients who stayed in resuscitation or ICUs, and we back to young patients and without comorbidities. They came mainly from another hospitalization. They were referred to us, actually. They were transferred from another hospital to our reanimation or ICU units, and they came to ICUs. They died in ICUs, and comorbidities, again, we find in the multivariate analysis, genetics, autoimmune pathologies, obesity, liver problems, and of course smoking as a risk factor. So roughly this is the description of the patients. So the study showed that the patients who died were very old. Most of them suffered from severe chronic pathologies, and this is where it's not original because it's in agreement with everything that's been said in the literature, which shows clearly that the risk of death depends strongly on the age and the previous health condition, and we had less than 10% under 65, only 6 who had no comorbidity, and they are patients who are young and more fragile, but still, some of them die and they're under 65 anyway.
What's the conclusion? Here, older and fragile patients must be the priority, must be the main target of vaccination if we consider that vaccination can limit the impact of the disease, so that the priority target. But we can also conclude that since we use the data collected during the hospitalization process, so we work in the research phase before the entry of patients, before patients being admitted in a hospital. So we think that there might be gains that we could actually update and think about the early treatment and a better management of inpatient treatment, because as you see there's some inpatient treatment that's quite chaotic, and we think that some patients might have been better treated, better detected. We also try to better identify high-risk patients. So there are solutions that are being put forward so we can better identify high-risk patients or to ensure the better treatment of high-risk patients. So we could monitor that. So I don't want to question the treatment, but we could implement monitoring processes and provide them with such barometers. And some articles were published about improving treatment, about better identifying and monitoring. But these monitoring tools could actually increase the number of hospitalizations, but they could also improve the way patients are treated. So that's what we are working on. Monitoring tools were implemented, and this is quite important because there are clinical symptoms that are not the same depending on the variant, but from what I've seen, there are still so what is quite in my presentation, I always talk about all the patients with comorbidity, so there's an impact of global life expectancy, but this impact is not visible because I talk about all the patients mainly, but if you look at medical records, if you interview patients, and if you work with clinicians, you see, well, that's my opinion, that there's an ethical issue here because many people died and they were isolated while they were treated. They couldn't receive visitors. And as clinicians says, there are people over 80 that can still go on living by themselves in their own home, but they faced a quite bleak everyday life. So we need to pay attention to the way we provide treatment inpatient and outpatients. We need to work with GP so we can better identify, we can improve the identification of patients, we can improve the treatment and the care process as a whole, and so that we can avoid the present situation from repeating. We can prevent it from repeating. So we've talked at great length of death of people, of deceased patients. We stop talking about them. This is quite ambivalent. The way we've handled the crisis is really paradoxical. So we've talked at great length of this. I agree. There was a lot of anxiety. We carried out interviews. People were scared. But nowadays, everybody, it's quite common these days. But they're still here. They still happen. Thank you.
No, I think there's another one. Okay. It's fine. Yeah, I guess. Go to the world interpreting. It's very good. It's very good. Just take this.
I'm not cabin, so I'm trying.
Yeah, okay, sure.
Nice to see you.
I will tomorrow. I was going to do a half in French, half in English. But my French isn't good enough. Now, if you interpret, you have to go English, French, French, English. You can do it? Yeah, we do. Like I do. Switch languages. And I might say, it's not very simple. No, but it's not actually. For people who listen, it's not very good.
I know.
It's better to stick to English. When I speak English, everybody has. Well, basically, yeah, they're all supposed to understand English.
It is possible, it is feasible, but our current system, information system, doesn't work very well at the moment. So we need to merge different data. And they are a pre-hospitalization data, but we do not have the necessary information system that would enable us to collect this data and to find out what really happened. So we need to connect the whole process, that is the first examination, the hospitalization and the treatment. ça coupe.
Ouais. Non mais les questions c'est pas la peine de question. Ça marche pas. J'en ai marre de sécher les barres là. C'est là que je sais que j'aurais pas pu être pute, tu vois. Surtout avec une mini-jupe de tabac aiguille et des bras qui grésillent, là tu peux penser invivable.
Là, c'est mort. C'est mort.
C'est foutu.
Tu vois, j'ai des collants pour demain.
Sure, please do. Ça. It's fun.
In public hospitals, but we're working on the matter and we work with the general medicine department. And there are many GPs who have created websites who are trying to provide treatment. I cannot tell you what's happening as for policies, I don't know. But from what we've observed during our interviews about hospitalization, there is the role of GPs hasn't been clearly defined. And the current treatment process, healthcare process, is still under construction, although 2 years have already passed, so maybe there wasn't enough therapeutical, there wasn't enough therapeutics, but maybe GPs can't handle oxygen at home, maybe they struggle to access scanners, so it's also about the number of cases there. This is a crucial element.
Décédés sans comorbidité, est-ce qu'il y a eu une décision d'autopsie qui a été faite derrière pour savoir, et parmi les 105 décès, est-ce qu'il y a eu des autopsies de réaliser
Not that I know. There were no autopsies. As for patients without comorbidities, some biological research was done to identify specific comorbidities, but maybe we should have done autopsies, but it's more complicated than that. So we reported 6 patients over a year, but between the moment of entry, where we were still missing elements, and now there's been an evolution, we know more, so maybe these people, this deceased patient with more comorbidities would have died today. So that's the main point. These patients that died in the beginning, patients with comorbidities, wouldn't have died today. I described patients who died in both university hospitals, but there are patients that died in retirement homes. They were both old and with comorbidities. Okay.
Juste une question.
We'll talk about a type of analysis of errors, mistakes that have been made by epidemiologists, that is, people working on models and that made projections from models. So I will mention a few strange mistakes that remain unnoticed by most people, and today I would like to imagine what it would have been to inform decisions thanks to scientific data. So what could we have done if we had used this tool to inform decisions? So I will mix science, but if we inform decision, is it still science, or are we bringing our expertise? I've never worked in the healthcare field, but I have worked on modeling, and I applied it on a social innovation, on diffusion of a social innovation. So I worked with the same models, but it's quite difficult to interpret these models because such models can make us understand who's sick, who's not, but then you can be influenced by general opinion, general public. So I've been making these models for 20, 25 years, but this past 5 years I've focused about the use of science to support decision making. And I've worked on people who provide doubt, who create doubts. They generate confusion when there are controversies in the industrial world. So they produce a specific discourse. So that's why I focus on this crisis, this health crisis, although I didn't know anything then 2 years ago, but I learned a lot from all the videos I've seen on TV, videos of specific people which I will not name, but I've also had discussions with my colleagues. And we focused on quantitative modeling, which means that we wanted to provide figures. That was our obsession, because we wanted to anticipate what was going to happen. Then, once we decided to make predictions, when we find out what the predictions were, we decided on what we could do. So there was not much, there was no connection anymore with the initial modeling. So they were countering models that showed what didn't happen because we implemented measures to prevent them from happening. But these models were never approved. We could never prove they were right because the predictions what we predicted never happened. So that's the core of the discussion. So there were three main kinds of models. There are, first of all, process models. So we can make them evolve. We describe the process. Those are processing models. And then there were functional models. They were used last September by the Pasteur Institute, among others, and the first model was the Ferguson model. These models were known to me. Those models will generate artificial environments. There's a program that will implement what we create. So we enter the information that the patient is sick, and the model will apply it. So we represent, we kind of produce, we create a world thanks to this model, and then we observe what we produce. So we produce hypotheses and then we observe what we've created. And then there are also more general models, and we can actually see agents talking to one another. And we could, it is just like the Sims video game, it is a highly representative tool. We create a whole universe. It is quite crucial to understand. But then there's a certain model, a compartmental model with agents that haven't been affected by the disease. We count the number of agents that are sick agents of agents that have recovered, and there is a ratio between the patients who are sick and the patients who have recovered. There is so we enter information from about what we know about the epidemic. It is quite a process-based model. We start with R0, we start with this, and we can predict the number of people who will be sick next week. As for functional models, I haven't studied it at length, but Vincent is an expert, is a model that is based on a parameter, an explanatory parameter. You look at the curve and you make projections, and nowadays it is just like the weather forecast. That's what Simon Cauchemet explained in a conference. They produce 10 models with different explanatory parameters, and then they make an average. So why would they use an average model? Is there any reason? And the creator said that it works. That's the way it works the best, but they never really explained how this works. So we've never really got a clear result that would make us approve or disapprove of a specific model. It is quite a vague projections. So you can produce a whole universe, and the forms will emerge, and we will only see what we're looking for. So these diffusion models were used with the Ferguson model. That was the first model that predicted that 300,000 people will die in France, but there was no time indication. So it just predicted that there would be 300,000 patients that would die at a specific moment, and that's a pity, really. It's quite sad. And that was an issue. There have been discussions in different forums at work. People disagreed. People opposed the fact that we accepted this kind of demonstration. Others said that we could be more optimistic, that the virus will be less and less dangerous, that at some point it will be harmless. But really quick, scientists said we needed to stop criticizing Ferguson, and we needed to stop saying that there will be no harm because we didn't know anything about it. But to me, these models were the best to discuss social problems, because these models represent interactions. Interactions are being represented with the duration, so you can actually have a reflection. You can actually try to determine what will happen if some connections are broken. So if we knew the situation on the ground well, we could have had a really good observation. But there's another issue. We cannot make any quantitative observation because we didn't have enough parameters to make an observation. Then we also used representative scales that were quite odd because they focused on France, while scale diffusion model are targeted. They're targeted to determine where the disease is circulating, and the disease will not jump from Marseille to Paris in a second. And then there is the time parameter. So So all this information should be treated separately. You cannot apply this tool on a whole country when there are only 4 areas where there's a cluster. Any model actually can assess the epidemic in different places, but they don't use the same measurements. You can actually do it. There are professionals that already know how to use these models. It's quite easy to do a brainstorming about it. But furthermore, you can talk about a model that is based on 500,000 people for 1 million people. These models are sensitive. It depends on the number of people. These models are hyper-dependent. So if you produced 10 different simulations with 10 different narratives with the same hypothesis, well, some models work. Some models lead to an epidemic, some models don't. And these models weren't discussed at all. They were absent from papers. And finally, with one of my colleagues, the two of us who work in social sciences, we have taken a stand, so we don't work in epidemiology or in physics. And we have criticized the structure and the topology of the network that must be known. And this was mentioned in another paper that said we cannot make predictions. You can work with models at any given moment, but you cannot make predictions. So this is the best we can find. I sent this to colleagues. I tried to convince people. So I wanted to say that this paper should be rejected. So there was a model with 194 parameters. 192 come from literature. Among the parameters, for example, you will go shopping 2.5 times a week, and you will meet 5 people while you go shopping. So that's a parameter that was used. So nowadays we use averages. We don't know where they come from. They can be surveys. They're not consistent. So if you take a population, some people have written a long thesis about populations, and they can, with these models, they can use 4 parameters that are territory linked, time linked. And that was not the case here. They only use a mean data. There were 22 hypotheses, and then there were also 2 other parameters that were quite strange. And so I showed this to a few colleagues, and they were quite surprised. So these models were quite obscured. So there's another issue I wanted to report about the use of RT. That is a number, the mean number of people that someone can infect while being infected himself. So it is quite difficult to determine this. It is quite difficult to make a choice. There's not a unique way of doing things, even if you're an expert. So these are estimates. So some very vague data were provided last year. So they used the RT. And it is quite difficult to work with this kind of tool. It is quite difficult to provide a figure to predict what's going to happen next week. This is not science. This is bad. Science doesn't authorize this. And there's something else that was quite interesting after the hypothesis didn't evolve. There wasn't any evolution, and I discussed with a few colleagues that kept on predicting the number of hospitalizations next week based on the number of current hospitalizations. So, but in 2020, we were questioning, so we were starting to make small predictions. We didn't have accurate figures, but they were trend based on measurements, the measurements that were corrected depending on the weather or other parameters. But now we're talking about models. And we're talking a lot about evidence-based science right nowadays. But well, these people kept on making predictions.
So after that, it showed people laughed in real time. I had, messages on Twitter, oh, yeah, they forecast this and that. Then people did ex-post analysis, quantified 9 times out of 10 predictions were wrong. I don't know if we can say 9 out of 10, but basically, but it was weird anyway. So it damages trust. Well, I understand that my colleagues didn't complain because we lost customers. That is, I come from modeling and, Ferguson type, okay, we've lost the trust of the... It's not complicated to put forward the idea of significant uncertainty because we can still talk, that's the point. And I would tend to talk about prospective rather than predictions. Prospective being more qualitative and the evaluation of possibilities and not the only to forecast something is going to happen or predict. And well, basically this is the type of model which are suited to this. So that's another thing I've been advocating for a long time. So those are models which are used in interdisciplinary domains. That is, they are used to do pedagogy or interdisciplinary pedagogy among people who want to work together and who don't use the same tools. They have a common ontology where everything can be translated to work together. So if you wanted to do interdisciplinary teams of true scientists, as we did for a nuclear bomb during the Second World War, well, you can have it. They even had people who hated one another in the same room by saying, let's work together. Like all researchers, they hated one another. But anyway, they were able to get them to work together despite their egos as physicists of the 40s. They had huge egos, but still. So it was possible to get people around models which could be a lingua franca, who would have a space for discussion, neutral space for discussion. And this is essential. And anyway, there was an experience, I'll talk about it at the end, called cooperation. We are model designers. We did a vulgarization website in March, April, May 2020 called Comprehension, where people could put questions about the dynamics of the epidemics, and we designed models. We did in real time, and we did it for pedagogy. We said, okay, this is how we would address this question. So in the site, you got 20 ways to modelize an epidemics from different people who asked different questions, and each time insisted on something essential, which showed that, well, the type of modeling, each model designer will have his own approach. Even for common questions, this aspect, it's not a truth. To get for a model to be true, it's difficult. Now, I want to show you here. Okay. Well, I don't understand how they can work like that, all those people. For example, here, this is a lovely curve. The population, well, all agents are linked by a small world, some kind of a network which corresponds more or less to the social behavior of humans. And if you put an agent who's sick in the 200, and then you put a transmission rule, they have a certain number of social networks, they gather, they get together, and here we go, you got a lovely epidemics shooting up here, We can plenty of we got plenty models, different models, which trigger epidemics. Then here, in red, put the confinement or lockdown by hand. Roughly, there I could see that it was becoming serious, so I'd locked down everybody. I had a peak, went down again, and I removed the confinement. I stopped the lockdown, and I just pressed keys on my model. But I've tested two other hypotheses. Well, you say, okay, well, it's not that easy to know if it is strikingly different or not. So my hypothesis is, well, when, this is what Didier Raoult says, the virus becomes less and less transmissible as the epidemics, and after a while the epidemics will stop transmitting. Okay, that's not depletion of the reservoir, it's reduction of infection potential in time. So I enter the parameter, and it goes down with according to a linear process. Just by adding that, here's the epidemics which will last 50 time steps maximum. So the fact that there is a slight curve, it drops when it disseminates, it blocks the epidemics, and then on green is a virus which after 40 time steps that is no longer transmitted. All of a sudden, people stop being sick, it stops, no transmission, but it starts again. After 60 time steps, it starts again. So it starts again. It's nothing, just easy to code this, 10 minutes to test an alternative hypothesis. And I could have several models in which I would test, do I put a virus that doesn't change, virus with a rapid endogen profile, and you can test the some of the actions in networks and so on and so forth. So what's interesting is that if I tried to do a confinement and the rebound, this famous wave, we say if we stop lockdown too early, there would be a rebound. Well, that's a clear artifact in the model. Systematically, you make that in models. Doesn't mean that it will happen in the reality, but in order to, it shows the basic curve, and to get the lockdown with stops, and I stopped it, and at one stage I apply it again. No, sorry. I put it and I stopped it because I thought, things are going better, but I was able to get, it's a simulation artifact. Well, if I do the hypothesis that I got a disease that will go, which is transmissible for only 30 time steps and come back. So how do you do, when you look at the curves, what is the underlying model that would be most relevant for that? So there is always the issue, during the is it the lockdown or is it another dynamics that caused it to stop? So one point I didn't mention, when you represent confinement here or lockdown, we took the same thing, okay? We took 70% of the links homogeneously for everybody. That's very important because it's completely false. We kept people who are still in contact with a lot of people. They become super spreaders, and others were not. That's important in dynamics. It doesn't cause the same dynamics. So to show you that you can tell just about anything. So this is one thing we wanted to test, because some people said, if we put lockdown at one side, in some locations, that there is a slight rebound at the time of lockdown. So it was said, and so we were thought, okay, what could cause that? The hypothesis was, because there is a multiplying rate when you're inside a house. If you got a lot of people in the population who are infected, then when they come home, they infect everybody, if they spend the whole day with them. So that's verbal. Okay, let's test if it works. Likewise, is the verbal description of a process, is it possible to implement it? In theory, but we fabricate a system that will produce something which corresponds to the discourse. Doesn't mean it's true. We cannot say it is stupid. And we thought, okay, so what's going to happen? When do we launch lockdown? You see lots of charts or curves. That's perfect lockdown, with the initiated from the start. It's, you know, everybody's already locked down, and then you see everything. That if you launch the lockdown here, well, you know, it doesn't have a significant effect. That's great lockdown. When you're at home, you don't infect more, and 70% of the links are cut in an homogeneous manner. Je perds le sens de son discours. Je ne sais pas de quoi il parle. So what would be the infection rate so that we would have a rebound, and when would there be a stage where with an infection rate inside the house which should be higher with date, which would be some kind late for the lockdown, there would be a rebound. So we make it, we fabricate it. So from the narratives, when people is at home, they get more affected. So if we put the lockdown too late in, then we'll have a rebound. We can fabricate it. Is the hypothesis the correct one? Well, you know, that's, I didn't, but all this tells us that there are alternative ways to describe precisely the same charts or curves, because each time, you know, we are being convinced with curves. It's possible. This is why it raises an issue, because this could have been fabricated and discussed. Well, we discussed, we tested several things, but one was of interest to me was the relative contribution at different times of the major events, because this was the logic to say once everybody has been highly infected, if you redo an event with 2,000 people, does it have the same impact? Do you have an impact similar as that you would have at the beginning of the situation? Well, likewise, we did. Those are simulations where people meet only in major events, or people who meet only, people who meet at home and in major events, and people who meet only, some are more than 50 friends, and some have 50 friends who are more spreaders. And this is epidemic curves with only relationship with only 10 friends, 12 friends each, and events from 100 agents with 120. Every 5 time steps there will be events with 100 agents. So you see here more people, and if you see in the middle people who are highly infecting or highly, you know, well, the epidemics will start faster and it lasts. But it doesn't last as long. So what we worked as the fact that major events in our model are less important than many small weddings with 20 people. If you got a lot of marriages with 20 people, well, you got, you know, weddings of 20 agents rather than events with 100 people. The peak will be higher. So it doesn't mean that's reality. It means that you can work on that. We can think about what would be the equivalent of relationships, whatever, but mainly. No. Mais qu'est-ce qu'elle nous fait, elle, là?
Combien de slides, là?
Hein?
Il y a combien de slides encore?
Non, c'est pas ça, mais surtout.
Tant pis. Bon, surtout, on avait créé une espèce de mesure pour
The kind of measurement to do the relative impact. That is a relative impact at a given time. We could know if the person has been infected in a major event, or the agent in a major event, or in daily life. And therefore, the indicator is a relative indicator where in time we can see, well, I can show you later on if you're interested. We can see that in fact there is the contribution of daily relationship, which affects a lot of people, versus the contribution of major events, which doesn't have much of an impact, and it varies in time. As a function of the population already impacted and already more likely, well, it will vary in time, but we can fabricate indicators. We can think about such situations. We can ask ourselves the questions, are there times in the epidemic? So I suppose that all this is known by the epidemiologists, conventional epidemiologists, non-modelizer. A lot of this knowledge has been acquired. Simply that to get into a domain where we know nothing, where we can set up indicators and reflections around that in 6 months, I understood everything. I ended up with my colleague Samuel Alison, who gave me definitions. I said, but that's in the model we've written that we understand that. So to say that a lot of work's been done and eventually did not include only one hypothesis that would occur in the environment. That is, well, possibly infectivity would decrease. Michael Derry, spent his time saying that this is not exponential. It's not a constant rate, it's a decreasing rate. This is exactly what we did before, and he spent his time saying that. Could have been integrated in the models, not difficult, but there was no dialogue. So, okay, here comes to the conclusion. We are with the flat earth. Well, okay, if we were, this is my argument against the fact that the earth is flat. It's on easy plots for to discuss in society. So, no, but conclusion is that the lack of dialogue and difficulty to talk was complicated, because it is true that, well, we came up with the book in September 2020. We existed, but anyway, there was a seminar which called Mod Core, where I heard people, very serious people, discuss about models, utilization of models, operational research applied in real time. Someone from Google did amazing work. So there was space. So I sent them the book, but they didn't invite me. So throughout the seminar season, I looked at the seminar, I wasn't invited. So, but since I am interested because I want to see how it works, I said nothing. I thought, well, it's interesting, but anyway. And I stopped asking questions because the question of R0, when in July 2020 we said Pasteur Institute calculated R0, but there is no, basic element, data not being available. How do you calculate R0? We load it into a model. I mean, you can't do that when you're a model designer. So little work done around the diffusion, but there were 2-3 models, but it was always we cut links in a homogeneous way. So it's not work on diffusion, but all measurements were, don't meet your neighbor because you cut the links. So there were tools which were not suited to work on the links, so which were never used, but we did this course on the links. So this is what I found mad. There is no accountability. There was no accountability, no transparency. There was no possibility to follow given reasoning for what had been never been used, or well, if there was a history. Overuse of quantitative data, that is the figure. To discuss a figure, you have to come up with another figure. To challenge a figure, you have to give another figure. And it could be quite difficult and very long. I remain quantitative. I don't do figures because I don't have the. You have to be good for that. And the research institution had a breakdown. A shame, because we could have done interesting things in research teams simply to better express hypotheses or eliminate things that didn't work. If we cannot fabricate a model based on a given hypothesis and it never leads to the emerging phenomena, 3, 4, we try, okay, this hypothesis doesn't work, we'll drop it. It may be used for that. Then it would have been pedagogical, interdisciplinary. Well, parts of the models have been used for a long time for that. And of course, we would have to work with scientists, with exchange discussions, and not as an expert paid, an expert who comes, gives an opinion, goes away, and does not work the explanations. We could have done great things. C'était quoi ce discours farfelu là? Ça partait dans tous les sens.
C'est pour ça que je suis pas partie.
En fait, je ne sais pas ce qu'elle démontre là.
Mais ce qui est dur quand même, c'est les effondrements de communautés, quoi. C'est-à-dire que moi là, il y a d'un coup effondrement de communautés intellectuelles, quoi. C'est-à-dire que d'un coup, on se dit mais qui?
You say, it should not have been me, There were people working on the epidemiology. There are experts of virology in my domain, colleagues who, they specialize in that, but at the time when they started saying, bullshit and, complotists, I mean, that's it. Nobody said anything in public, in no community. It was a tragedy in terms of scientific dialogue. It was the case everywhere, doctors, journalists, you know, everywhere. Yeah, I know. It was tragic, yeah. USSR, says one. Welcome to USSR, says one. So, bon, là, tout le monde parle en même temps, c'est le bordel, là. I thought that we would have institutions would create, you know, we had sacred visions of our institutions. But, well, sorry, we're not getting the sound from the room. There's a discussion, but we're not getting the microphone. Si tu veux y aller, vas-y, là, c'est fini. Si tu veux y aller, vas-y, c'est fini, là.
Hein? Ça fait une demi-heure que tu traduis.
De quoi?
J'ai pas envie de te laisser...
Bon, c'est fini, c'était la dernière, de toute façon.
Ouais.
Non, attends, si je te dis que tu peux partir, c'est que tu peux partir.
Je suis pas partie parce que je l'ai vu partir avec ses 15 diapositives.
On ne peut pas considérer, parce que si je me souviens bien, dans les modélisations de Ferguson du début, il y avait une annexe où il avait décliné son supermodèle sur plein d'autres pays, dont la Suède. Et donc, on a un point de référence quand même, qui est un cas de non-confinement en Suède. Et donc lui, il arrivait à 90 000 et au bout de 2 ans, on est à 13 000 ou un truc comme ça.
Moi, je suis contente que vous parliez
de... un facteur 7, ce qui est vachement, ce qui est de la part de Ferguson quand même super sympa, parce que généralement, c'est plutôt des facteurs 100 000. Donc,
mais 7 en longtemps en plus. Pas en une vague. Hein. Mais non, mais ce qui est bizarre en plus, c'est que Ferguson était connu pour ça. C'est ça que quand vous dites ça. Mais je suis d'accord qu'il y a un contrefactuel.
Counterfactual. And we dealt with Sweden too, because I was very pro-Swedish at one time. And indeed, you know, in Twitter we said that that was my characteristic because I was told that I was pro-Sweden. But anyway, I didn't do the verification because it is so odd. I'm not quantitative as such, but when I see things which are completely absurd, you know, I stop and I wait for people to do, you know, people did they did a demonstration, not times, you know, more than 10% error for the, so I didn't check, but you know, it's true that we could do a counterfactual narrative about Sweden. But again, they say no, people they're away from one another, but population density is not the same. You say, yeah, because they live in a metropolis, you know, very much like our metropolises. So there are always arguments to come and say that it won't be a factual control, but data is not as good as the model, you know. I mean, that's what they say when you come that data is not as control factor as the model. Well, and to coordinate people around a common ontology. We can come up with very different ontologies from what, you know, what is a signifying entity and so on and so forth. And with this type of model, we can define all the representations of everybody together. And that's an advantage to get people to work in interdisciplinary mode, but prediction, never.
elle est très critique, etc. Tu démontres correctement les choses, mais tu vas pas jusqu'au bout parce que tu continues à croire que l'épidémiologie pourrait être une science. Et donc qu'on pourrait construire éventuellement en améliorant les modèles, en discutant un peu plus les uns avec les autres, en étant dans un environnement, etc. Bon, pour moi, le seul intérêt de l'épidémiologie, c'est de montrer que c'est le scientisme par excellence. Et ça a toujours été le scientisme par excellence. Il n'y a jamais eu un gramme de science en épidémiologie.
Dans ces cas-là, c'est tous les modèles.
Ouais,
C'est
et
le
nous,
modèle, justement, c'est ça que je suis en train de te dire, parce que vous employez les épidémiologistes en fond de modèle, et c'est une première critique que j'ai compris quand j'ai étudié le modèle ici en guillemets, c'est les équations. Une équation, c'est pas un modèle. Un modèle, c'est quand l'équation, effectivement, a été confrontée au réel, peut être reproductible, peut effectivement servir d'explication. Et quand on parle de l'équation de Boltzmann, c'est un modèle. C'est un modèle parce qu'on a d'abord une équation, c'est-à-dire des choses éternelles, et puis après on les a confrontées, on a fait des expériences, et à ce moment-là, la notion de modèle prend son sens. Et en fait, quand les épidémiologistes ont toujours demandé Cauchez, il dit il te fait un modèle. Et on a porté plainte, au pénal. Les pour dire non, un modèle c'est pas ça. Et quand tu dis que tu fais un modèle, tu fais croire que tu es en train de faire en gros le modèle de la gravitation, justement, la science physique par excellence, la prédiction par excellence, quand bien même tu poses des équations qui sont des chimères complexes, et avec lesquelles de toute façon tu ne t'y retrouves jamais, parce qu'il n'y a rien à espérer de tout ça. Donc le fait même d'employer sans arrêt le mot de modèle, c'est la preuve absolue, que on est dans le scientisme et pas dans la science, c'est-à-dire la mauvaise compréhension de la science, qu'on essaie d'imiter de manière presque mimétique, si tu veux.
sorry, the off microphone discussion and we cannot translate. Sorry about that.
Les économistes sont exactement de la même tendance. Et d'ailleurs, c'est pour ça qu'aujourd'hui, c'est le Conseil d'analyse économique qui fait les études épidémiologiques. Quand même. Ça, c'est remarquable. C'est-à-dire qu'on a reproché à Laurent Toubiana de ne pas être dans son domaine, à Pierre Chaillot d'être un statisticien là. Et aujourd'hui, c'est les économistes qui font les modèles en épidémiologie. Donc c'est bien pour dire qu'il y a quand même un petit problème. Et en fait, les deux, quand tu les regardes, se construisent sur une espèce de physique statistique. C'est-à-dire, on prend comme modèle la physique et on essaie de mimer sur des objets qui ne sont pas justement modélisables comme des objets physiques, en fait, des méthodes. Et donc, on en arrive à la conclusion que...
Attends, il y avait des gens qui tenaient ton discours en physique à la fin du 19e. Quand la physique a commencé à utiliser de la modélisation mathématique, ils ont dit exactement la même chose. Et je crois que Comte a dit que c'était du charlatanisme. Si. Non. Historiquement, tu dois aller vérifier. L'apparition des modèles en physique, ça a eu exactement la même réflexion que ce que tu es en train de dire. Et le problème, c'est que tu dis que modèle, c'est synonyme de modèle juste. Et ça n'a aucun rapport. Tu peux faire des modèles qui sont des modèles utiles. C'est pas la même chose qu'un modèle juste. C'est pas obligé de dire que tes prédictions sont justes et vont être vraies. C'est autre chose.
Okay, sorry. All this is most interesting indeed, but at least here we have a discussion. Okay, we still have tomorrow, and as of 9 o'clock, and not 9:30. So, at 9 o'clock tomorrow. Thank you. Bye-bye. Putain, ils étaient en train de s'échauffer.